Hello, everyone, and welcome to the Hyperthesis podcast, episode number 56. I'm Patrick.
I'm Pheely.
And I'm Liam.
Well, today we have a special episode for you, seeing as we are now at the final episode of our 4th season. So we're aiming for about 14 episodes per season, give or take some. And this is episode number 56. So this is the last episode of the season, and we wanted to do something special. Just instead of having a main topic that we'll be discussing in a specific story and specific introductory concepts or topics, we are instead just going to be having, as Pheely has called it, the ultimate chill episode. I kind of see it as like the faculty lounge after hours episode. But this might go a bit longer. In fact, it will go a bit longer. And it will just be us discussing different things in science that interest us. We'll still kind of stick to the usual. We'll do some intro topics, some main stuff, and then maybe some stories about ourselves. We'll see. But just set your expectations a bit lower for this episode or a bit higher if you want to really hear about us and what our thoughts are on different science things. But yeah, welcome to the season finale.
Well, also what comes to be this is also like, this is beginning of September in a couple of days, which means I think in North America is when school starts. So this is the last time we're going to have this kind of more relaxed atmosphere before all the teaching assistants starts and, students start coming in. So I think it's a good time to start to relax a little bit before the storm starts.
And we did this once before, I think, right at the end of the first or second season. I don't remember, but we had a chill episode before where we basically just kind of talked about whatever we wanted. And I know, Patrick, you just said it'll be like similar in spirit. There'll be like intro topics, a main topic, and so on. But I think this episode's just going to be more like we talk about whatever we feel like. I mean, maybe it'll be like that, but I definitely do not have anything prepared, really. I have one thing prepared, though. One quick thing I better talk about before I lose track and forget. So in the last episode, we talked about these fancy quasi-particle things. Go listen to that if you're interested. But there was one type of quasi-particle that I wanted to talk about that I completely just forgot. I just skipped over it in my notes by accident. And these are quasi-particles called Cooper pairs, which actually came up in our recent superconductivity episode. Excuse me. Cooper pairs are very important for superconductivity, and I won't get into that. Or they're important for at least low temperature superconductors. I don't actually know if they're important for higher temperature ones. But what can happen in a superconductor is that you get these electrons moving around in certain ways, and what happens is that as the electron moves through a superconducting material, it can leave kind of this empty region behind it, and that empty region will act like a hole that has a positive charge, so other electrons can actually follow around other electrons. It's like you kind of get these pairs of electrons moving around as if they're one particle. So that's just, they're very important in superconductivity. We talked about them a little bit before, and I just wanted to point them out.
Well, I think it's similar to, I think we talked about it before. It's, basically it's that one electron basically guiding, like what's called digging the tunnel, allowing all the electrons to flow freely without friction, right? So that's pretty cool phenomena.
Yeah, I guess it's kind of like I don't know if this is a good analogy or not, but it's like if you're in a bathtub, you got your rubber ducky floating there. If you scoop a bunch of water up with the bucket, all the rest of the water just flows into where you just took the water from, and the rubber ducky will kind of move towards where you just scooped the water out of. And that's my theoretical physicist ideal situation where you don't create a ton of waves and splash things around, but yeah, it's the electron kind of makes a hole, and then the other electron will follow it around. So you get these pairs of these Cooper pairs of electrons that move around. They're two fermions, yet when you have two of them, they behave like a boson as well. So they've come up a few times, and I just wanted to point out that they're a type of quasi-particle as well.
Also, from that episode, I believe we mentioned that they are the main superconductive mechanism for, I believe it was type 1 superconductors. So where
Well,
you
that was
have
from that was from the superconductivity episode. But I wanted to talk about these in the quasi-particle episode. But so what were you saying about the superconducting episode?
just that they are associated with type 1 superconductors, and that's where the theory came from. Type 2 superconductors, so higher temperature superconductors, different mechanism, we assume, than Cooper pairs. So just want to touch on that.
Excellent. Thank you. All right. So what have you guys been up to today?
Before we get into that, I do have another thing I just want to mention. It's really cool space news, and it's the Indian moon lander. So
Oh,
the Chandrayaan 3 is the first probe to land on the moon from India, and this made India now the fourth nation to actually stick a lunar landing and put something on the moon. So this is very exciting news, just because it's the first probe and the first rover and a whole bunch of other things that are near the south pole of the moon. So it was able to touch down on August 23rd near the south pole, so not exactly on it, but somewhere close. And it has a whole bunch of different instruments and a few goals associated with it. But a cool thing is it's a lander, so it can't move, but it has a built-in rover. So the rover, I believe just earlier, today or yesterday, very recently, it rolled out of the rover and was able to roll a little bit, which is very exciting. And given that this is happening in 2023, there is live footage of this landing. There is a lot of interesting, I guess, modern day aspects to it where we're actually able to see things happening in real time or near real time and at high quality, high resolution, and it's just very exciting.
is this the first one that's been at the south pole of the moon? Did you say that? I might have missed it if you did.
Yes, yeah. So it's the
Yeah.
first probe that's landed close to the south pole. So it's at uh just a few degrees away from the south pole.
I also oh sorry. I was gonna say I also saw on social media, so citation needed, but that this was a relatively I don't want to say low cost. I'm sure it was very expensive, but compared to the original ones or moon landings people do today, it was definitely not as expensive as something say NASA might do, which I don't know if that's true or not. I just saw it on social media somewhere. And that's actually kind of it's a good thing in some sense. You might think, oh, well, cheaper's worse, but also if you can send a rover to the moon, or sorry, a moon lander to the moon for less money and it's successful, then you did a better job, kind of in terms of sending things up. You can do it more often, cheaper. It's progress.
Well, it depends on how they make it cheaper because like where is the most cost? Is it the fuel? Is it the technology? Is it the hiring the
Hmm.
people? So I don't know which part contributes most to the cost of, let's say, sending stuff to space. But let's say the fuel cost is the most because there's a lot of fuel, right? Like, so does it mean that like the country with access to oil or some type of fuel would make it cheaper? It just there's a lot of variables that come into predicting the cost of spacecraft and space missions.
Yeah, I guess there's so many degrees of freedom, like things, parameters you got to take into account, right? Like, and also, again, I don't know if this is true, so I need to go look this up. But cheaper things break faster usually, so it could be a question of how long. I guess we'll only know once this lander's been up there for quite a while if it was really good, because a lot of these landers I find that they tend to go up to the moon and they last way longer than they were ever designed to, which is good. You see these like moon rovers going around like many years past their predicted expiry date and doing way more than they were supposed to. So I'm interested to see how this one does.
So the interesting thing with this is it only has a life expected mission span of 14 days, which is half a lunar day,
Oh,
technically. So it
that's nothing.
exactly anything past that and you're set. But the interesting thing about the moon and why we don't hear so much from them, and whereas Mars, we have like the Curiosity rover and the Perseverance and the Spirit and Opportunity and all these rovers, um, the moon poses its own risks to these rovers and to anyone that goes there because it has regolith, which is its kind of sandy like material, but it's not sandy in that it's sharp and usually has sharp edges and points, which does a lot of damage. So the moon poses very interesting problems since it has no atmosphere, it has no erosion, it has no liquid water or anything. So this regolith is able to essentially cut away at things or really quickly degrade different materials. So, for example, this is a lander, so we might not see too much damage to the lander itself, aside from the regolith that kicked up when it landed, but the rover will see what kind of condition that's in when it comes back.
Well, talking about Mars, right? Like, is such an interesting thing too. I was thinking about it, about human experience when, let's say, the first people like arrive on Mars, and you walk out in your spacesuits, and you probably experience something, the scenery or the experience, the feeling that nobody else on the planet, even those people who went to the moon or went to space, has ever experienced. The vista, the maybe the sandiness of it, or I don't know what it's going to be like now actually on the surface. We have guesses, but we don't know what it feels like to look upon that scenery. We might know from the photograph and video, what color, what it really kind of looked like. But I think being there, experience for the first time of like, hey, we are on another completely different planet that nobody else has ever been, allegedly. And it must be such an crowning achievement of experience.
So, for those that like to think about that kind of thing, what it would be like to step foot on Mars and to maybe live on Mars and develop a society on Mars, I would recommend the Mars series or the Mars trilogy. So, it's Red Mars, Green Mars, and Blue Mars, which is a trilogy that kind of highlights sending 100 essentially colonists to Mars, I think around the 2030s or 2040s. So, not quite close, but it's actually quite accurate and scientific, at least in the first book. And then it kind of follows Martian society as it develops and its interdependencies on Earth and vice versa, and just kind of how different technologies and different situations would play out on Mars as people began to move there and as terraforming became more and more possible to the point where people can just walk outside on Mars without any spacesuit or anything. Really interesting series, very descriptive. It's a bit of a long haul, but if you're into that, I would recommend.
So becoming an astronaut is a very hard thing to do. You have to go through, I mean, a lot of scientific training. I don't know what the specifications are and what you need to have to be an astronaut, but I think like every astronaut has a PhD in something, and they're all no. Okay, I don't know. Well, like many astronauts you see have PhDs. I've noticed, or they're doctors or engineers or something.
Early astronauts are actually like soldiers, right? So
Yeah. Well, I'm
yeah,
talking about like modern astronauts. I'm not talking about a lot of them were pilots too.
it depends on why would you go to space. Right now, it's just they do scientific experiments on space. What author's purpose is there to go to space rather than other than like doing research,
Mhm.
try to figure out how to go to other places. I really don't see much point of going to space apart from like scientific research. Some people will want to go to it for fun, but I wouldn't, because like there's so much risk involved that for that tiny bit of experience without the duty and responsibility that you carry for humanity, I don't think is really worthwhile just to satisfy your desire.
Yeah, but so here's even the astronauts that don't have PhDs, like they get so much. They're very smart people. They get a ton of training, both physical, mental, and scientific, about how to do what they're going to do. So it's a hard process. But my question is that if you were just offered today, like, all right, we're going to take you to Mars. You'll be one of the first 100 people to go there and live there, and you didn't have to do any of that crazy hard training. They just, uploaded it into your mind or something. Would you go to Mars? It's a risk, right? You might not. You'll never come back to Earth probably, and you might die.
Actually, I said no. I actually would never go to Mars because I don't live that long. And I think on Earth, there's enough for all of us. I don't think Earth is near capacity at all. There's a lot of things we could do. If humanity, put our minds to it, we can feed everybody. We can eradicate poverty right now. I mean, we have enough food to go around. But there's debate on how to distribute it and stuff. But I think we can figure it out. If we finally reach capacity, I think in the next probably 300 or 400 years, then hopefully we'll be able to establish colony on Mars or other planet, asteroids, or even some station in space.
I'm kind of the same way. Like, I think it would be very, very incredible and a wonderful experience to even just go into space for like 10 minutes or something, just to like see the Earth and see space and see the sun. I mean, maybe don't look directly at the sun, but I think it would be so cool. But I'm also very, very happy just being on Earth. It's very risky to go into space, and we were built for this planet. We were not built differently.
And also, I think it's a generation thing. I think our generation has really strong attachment to Earth still, because in a way we grew up knowing about space, but we didn't know that much about space either. Well, compared to let's say 1900, we know a lot more. But compared to let's say like the children or the generation that would be our children would grow up knowing so much about space, knowing that it's actually plausible to colonize Mars and have like a strategy to it. I think growing up, we heard about Mars is livable, or could be livable, but we had no strategy, or I didn't know any strategy that is as concrete as I know now, even though it's not very concrete, right? So I think there's then an element of that too.
Maybe I'm a bit different than others in the generation. And nowadays, I would say I would stay on Earth and not take a one-way trip to Mars. Just I've settled with people around me that I care about deeply. But if you'd asked me 8, 10, maybe even 5 years ago, I would have said yes. I mean, one of my dreams has been to be an astronaut. I will absolutely be applying the next round that Canadian astronauts are applications are being accepted.
Ooh,
We'll see how that goes. Hopefully I'm done the PhD by then.
that'd be really cool. I could like tell people I know an astronaut.
But I guess the benefit of being an astronaut nowadays is that you go 400 kilometers away. You go up and you're orbiting the Earth. You don't leave sight of Earth. And I mean, nowadays it's no less risky than driving to work or something like that. Maybe a bit riskier. We'll see how the SpaceX rockets go. But
if you live in Toronto, that's probably riskier, honestly.
Take shorter to get to space than to work in Toronto too.
Yeah, honestly.
Well, I like to think when of all these missions and stuff. That's why I really hate those like commercial space stuff. Well, I mean, because to me, in a sense, it's a noble cause. You're bearing the responsibility, because to send someone to space, it consumes a lot of resources. Like fuel and manpower and all this stuff, to have an opportunity to provide humanity of more knowledge, of more understanding of the physical world of the future. So in a way, when you go up there, you show the responsibility of humanities. You have to learn, be a noble person to be able to take that you're carrying on your shoulders the future of mankind, not just there for fun, right? Like Well, even though you perhaps can have fun, you might have enjoy it very much, but the underlying principle of space exploration or exploration in general, navigation in general, is to further like understand of mankind and hopefully provide a new place and to provide resources to sustain humanity. To me, is such a bigger accountability that you have to take in mind when you people go to space or do some like um, collective projects for humanity.
I have the same thought. Is that I don't like this whole commercial spacecraft stuff very much. I mean, I'm sure there's parts of it that are useful, but I mean, right before we started this podcast, we're like, all right, no politics on the chill episode, but rich people doing rich person things just because they can, regardless of how it affects the earth, is always something I don't like.
Yeah, I
So
mean, people do many things to satisfy their desires, right? I mean, it's very fundamental to being humans, actually. Like, so I
yeah,
I can see why, but whether to support it is another issue, right? So like, I can see
yeah. I
why.
mean,
Well, if you were in that position, if you can, right? If you can, why wouldn't you? And I think that's the reason why we need like to discuss morality, ethics, and other part. Is why I love that branch of philosophy so much. But that's a conversation for another podcast, I think.
yeah. It's Patrick has his hand up, but I think there needs to be more space policy that all the countries of the world come together and agree on. But I mean, that's going to be something that's hard to do in the first place. But you need space policy because right now, I mean, I don't know how it works now, but pretty much anyone can just fire up satellites whenever they want, well, willy nilly, and it's going to cause problems in the future for the world. So you need like a UN of space, and I think that exists, but not every country's on it, of course. So
If I'm not mistaken, I think the UN does have like a space sector, similar to its other
mhm.
organizations within the larger organization. And I must say, while I agree that billionaires doing billionaire stuff just because they can is silly and maybe not the best use of resources, there is something to be said for the advancements that private space flight has brought to the table that would otherwise be bogged down by
True.
politics or death by overplanning, such as something like the space shuttle. It took longer to actually get going, and there were a lot of compromises where I think the Air Force wanted it to be able to be a fixed wing descent vehicle, but not quite right for coming from space for scientific purposes. So there were a lot of issues with that. Whereas a company like SpaceX, well, I'll keep my opinions about owners of SpaceX aside, they worked fast, they broke stuff, but they did also make a lot of advancements. And now they are in partnership with NASA to fly people to the space station and fly projects up into orbit, which is excellent because it's cheaper and it's also actually making progress because we're still working on this SLS project, the Space Launch System, that's been in the works for many years. And I mean, we sent an empty capsule to the moon and to orbit around the moon, but who knows who's going to get to the moon first again?
Well, I think it's still the same problem of motivation. Like, I don't think. Well, I think private sector really make it faster, of course, because without the bureaucracy and funding and those issues. But still, I think the like changing the motivation is has nothing to do with the operations of private sector. I mean, you could have a private company up to space, but their purpose is not to just for pleasure. Even though pleasure is very convincing arguments, like come on, everyone, all the little boys, girls, they want to go to space, right? Like so it makes sense that there's someone's dream that have a lot of money to want to do that. Absolutely, right? And that's the point of having a free country or freedom. That if you can, why not? And but I would like to see someone who is motivated to to create a private sector that just the purpose is to further humanity, which I think a lot of those people ended up working for like a kind of more like governmental projects and such. But to move away from the space stuff a little bit, I think there's a little thing I want to talk about. I think is have some relations to the beginning of this podcast, because I think one of the main impetus that to create this podcast is to keep our knowledge fresh, and which I think during COVID was a little stale, right? Because we kind of stayed home and then got stuck in our own mind and our own projects, our own groups, and not really engage intellect like we usually supposed to do. So in a way, how are you guys now keeping your you know knowledge fresh and ready to go?
I do a few, yeah, keeping on top of knowledge is, well, in our field in physics, right? Like, you have to stay on top of the literature, and in your field, if a new paper comes out, you have to read it or scan through it at the very least, or I guess at the very, very least, read its abstract. So this podcast is great for that. Like you said, we talk about a lot of science and physics and other things that we normally wouldn't. So it keeps us on top of that. Like, I had a conversation the other day with a guy about biomimicry, which is something we had an episode on once, and I knew at least some bare minimum stuff about it because I had to go research it at one point to talk about. So stuff like that is actually kind of useful. And even sometimes in my research, I'll be like, oh, there was this paper we talked about once in the podcast, and I'll go look at it and like see it and be, oh, there's some mathing in there, I need it. So this podcast has been great for that. One other thing I do is well, Pheely, you run a journal club as well, and I run a journal club too. Um, and that's a bit more. It's a bit more focused on kind of like the math behind these physics papers. Where in this podcast we just kind of hand wave our way through it usually, without talking too much about math, because it's hard to talk about math without a chalkboard. So the journal club on top, as in addition to this podcast, really helped me stay on top of things like new science and discoveries and things like that.
Yeah, for me, I honestly have been the past few years, I kind of steer not away from physics, but most of thoughts have been in my mind that keep me awake because the physics stuff kind of lose its shine, even though I'm still really interested in it, in the core of it, but it's not as wow as it used to be when I was younger. I think part of that fact is because I didn't know a lot growing up. Well, every child don't know much, right? Like is like makes sense, but let's say the degree of surprise has been really not much, because now once you know the literature where we are in terms of our scientific discovery, you can expect what to find next. Like, for example, if tomorrow someone told me like, oh, we found dark matter, I was like, well, I'm not surprised. Why? Because we've been looking for it. Like, most of the things that could be discovered or could be the news tomorrow, we already have some idea that we are looking for it. However, when we are growing up, we see this. Like when I first learned about dark matter for the first time, like black holes for the first time, there was this abrupt, this continuous jump in my feelings. Like, wow, it feels great. But now it just feels a little more dull. Basically, that everything is predictable. So in a way, I'm involving myself more in terms of philosophy and things that more abstract and metaphysical in a way.
It's interesting that you mentioned that it kind of became dull or unsurprising, because that's one of the reasons why I switched from physics into a different field. Was I felt like I had achieved what I sought out to do, whereas that was to, okay, become a physicist, did that, study physics and learn all about it, did that for the most part. Some things still elude me, but at the end of my master's, I was, or even not quite at the end of my master's, I was feeling, okay, I'm kind of reaching the point where I want to explore new things. And that's what I did. So I started a PhD in earth sciences, which has been fantastic because everything that I learn is fresh. I have very little background knowledge about well, at least I start with little background knowledge about remote sensing and forests and how trees work, how spectroscopy really works on the global level, and all these different things. And even now, I'm between a couple research projects, and I'm just finding new things to include or new things that I'm learning, which I would say keeps it very, very fresh. Whereas with physics, you kind of, and I have a rant about this later, but you kind of get into this such a niche topic that you know what to expect. Like these experiments take years to do, and then if they produce a result, it's like, okay, cool, that's what we expected. If they don't, it's like, okay, well, we'll look here next, kind of thing.
Well, I think even though I have those thoughts too on physics, but the one thing that really, really like hooked me onto physics, like inherently into me, was mathematics. Because even though we can discuss ethics, philosophy, all these part, it doesn't involve much of mathematics. And to me, mathematics is very intuitive to me. Not too intuitive like some geniuses, but I think I have some good grasp on basic fundamental mathematics, calculus, and algebra, all these different geometry, and those really to me are absolutely stunning. And even though sometimes I look at other things that metaphysical, that are more abstract, and I find surprising things or interesting things, at the end of the day, when I come back down to the pen and paper and doing math, I just realized the descriptions that mathematics can provide in terms of physical world and our physical phenomena that we see in every day or maybe rare events are absolutely beautiful, and it's such a good tool to analyze the physical world that I can't really discount it at all. It's such an amazing tool. I can't speak enough about how important mathematics, how crucial, how vital it is in human history into figuring out the world around us, the world that we live in. And even though when I tap into philosophy or more qualitative thing, which is fantastic field in itself, I just find myself reorient into what I find that what I do best, and I'm happy when I do things I'm good at. Right? I think it's true to all of us. And Liam and I sometimes discuss some mathematics, our theories in physics, and you realize it's such a great common language. Because when you try to explain someone philosophy, sometimes you have to really take like, I don't know, 10 minutes on like this thing. And I can give Liam an equation, and they're like, yeah, here it is. Like, oh, this is how it works. Absolutely. And there's this vast library that people have this common knowledge on. If you know calculus, you can show the equations, and you're like, oh, this is this type of differential equation. This is how it works, and it's just fascinating.
Yeah, that's why I got into physics, because I really liked math in high school. And I think it just kind of amazed me at how math can be used to predict the universe. Because historically, physics and science in general was, I don't know the dates and who did like the scientists, but historically people did physics to match predictions. They're like, oh, here's something we observed. We don't, let's take some math and mess around with it until it describes that phenomena. But then eventually people realize like, oh, we can take the math and do things to it to predict phenomena. And that I think is very cool. And that's what I really like about physics. Like even these simple physics labs you do in first year engineering labs or physics student labs, you have like a ball and swinging from a rope. You have a pendulum, and you can sit down and say like, all right, let's create some model, and you get some equation, and you make some assumptions, and you can predict what's the acceleration due to gravity on Earth, and then you can do the experiment, and it matches, and that's kind of mind blowing to me. So that's what really got me into physics, I guess.
I think that is a good joint to move into. I want to talk a little bit about the movie Oppenheimer that came out not too long ago.
It feels so random. So I'm going to
And
topic switch.
Well, no, because we talk about things that describe nature and describe, and I think a lot of the
Mm,
themes
okay.
in the movie really reignites me to be curious about physics again.
Yeah, I guess people didn't witness a nuclear bomb and then create math to describe it. They predicted some math or some science with physics, and they said, "Oh, snap! Like we can create a nuclear bomb."
Okay. So I
Oh,
finally
okay, we
saw
can talk about it
Oppenheimer.
now.
Yeah, we can talk about it. I saw it last week, so I have so much to say on it.
Well, okay, because the beginning, the first act of the movie is actually resonates with me. I watched it with our mutual friend, you know, who went to LSU. We know who he is, and yeah, it was great, and it was in Montreal, um, and theater was all right. I watched it in IMAX, of course, and
Yeah.
it has to be, and we go for aspect ratio over resolution because both of us have glasses on. We're like, yeah, resolution. We don't care that much. Our eyes are not 2020. Our sharpness is not perfect. I rather have more information on the screen than less, right? So anyway, so what really resonates with me was the first act when Oppenheimer basically start discovering or like learning or studying to become physicist, and the fact I the even though I think people might think it's like hyperbole or exaggeration where see visions and get tormented at night by the visions of how the world works. It happens. It happened to me. I'm sure it happens to a lot of people who do physics too, that we have this idea of the physical world, or even not even like the word electrons, right? Like how fundamentally things work in nature, and we have our own idea how it works, and we basically build on that idea over and over again in our head. Like I would just go to bed and not be able to sleep because I don't see the vivid visions of those things, but that idea keeps sparking. There's an atom, there's nucleus, there's you know electron. How do the electrons work? How does orbitals work? How those things work? And those thoughts continue and continue and continue over and over again throughout the night. And I just couldn't sleep. So I think there is a really real element to it. And the next part I want to talk about it is that um, I think in the modern physicist way, we kind of forgot that, when we do physics, it used to be that we are on the frontier of humanity, researching knowledge. Everybody dressed well, wearing suit and tie to work, because it was an important thing in humanity to figure this stuff out.
So that's something for me that kind of stuck out with Oppenheimer was the difference in how they were doing physics, or at least dramatized to do physics, versus how it's done today. And I left that movie also feeling like, maybe I should try and go back into physics, but that went away after a night's sleep. Um, but it was also interesting to see that because I remember before entering university, even reading about all these different physics experiments and these great physicists who were theorists and experimentalists. And I think that period of time that Oppenheimer is focused around, and a bit earlier, maybe a bit later, that was kind of glorified and everything because it's like, oh, this is the Heisenberg uncertainty principle. Oh, here's Einstein's equations of relativity. And you had these uh, kind of so many things going on, so many new things to discover. I like to kind of compare it to a tree where you have a nice, gorgeous, filled out fruit tree. It goes way high up to beyond what you can see. And so all these physicists were picking off the low hanging fruit, and they were able to be like, oh, well, this is an interesting fruit. Let's study it. Okay, here's another one. These experiments were run. And then the theorists would go ahead and say, okay, this is probably how it works. Like, spoiler alert, in Oppenheimer, when it's discovered that some Germans had discovered that a nucleus can be fissile. And then Oppenheimer said, no, the math doesn't work out. But they were able to do it at Berkeley in Lawrence's lab. And so that kind of back and forth, and of course the nice suits and the interactions we did have small class sizes in our undergraduate, but it wasn't quite like how they represented in the movie or like the pictures that you see of, say, Einstein lecturing at Princeton or different things. And so now all the low hanging fruit has been picked and we can't see where the fruit is up high. So we're like using theorists to be like, okay, it might be up here, and then like trying to shoot it down without actually knowing if it is actually there. So it was really interesting to see like this kind of glorified concept of physics, but one that at least I had read about for a long time, and then comparing that with my actual experience in
Well,
physics.
so when I was in Europe for a month at Cambridge University doing some stuff there, I noticed that I mean, at least at Cambridge, I haven't been to too many universities in Europe, but I oh, when I was in Italy too, it feels like science in Europe, at least physics, is way more similar to how it was portrayed in Oppenheimer than it is in North America. In North America, it's very like it's become so modern. Like you got to go fast, you got to get results. You got to have why are you doing it? It has to be important. But when I was in at Cambridge and in Italy in Trento, it was people were just doing research because they wanted to know, and it felt very much more like that intro to Oppenheimer, where things are more free flowing. It's more about just learning than it is like how do you patent this thing and make money. It was really nice actually.
Well, I think there's an element of capitalism that comes in, but it's not that much.
Well, it
But
probably
I
is.
think going back to Patrick's point too about different eras, I think Oppenheimer brought quantum mechanics to North America. So now, when we grow up, even when we want to learn fundamentally about quantum mechanics, we can put it out in your favorite search engine on the internet, and you can learn it. But back then, imagine you don't know anything about quantum mechanics. You don't even know it exists. And you cannot know it because there's no information sharing system that allows you to do that. So the only way is to attend those lectures. And you better hope that those lecturers are good, right? So that's why, like, imagine being Oppenheimer disciples, right? You go into the class, you don't know what they're going to teach. It's not in any textbook that's there at the time, or it's not well publicized. It's a new thing. It's a like when you introduce like the concept like, oh, maybe black holes is this thing, but nobody thought of that, and the magnitude of the impact is different. Even though right now, if they go to a lecture about something new, like the first time people maybe heard about like the Higgs bosons, right, the God's particle, whatever, it's not the same magnitude as like, hey, this is the first Einstein lecture on general relativity. That is that magnitude, that the fundamental theory that came on, that's such a monumental piece that doesn't exist anymore because those became the foundation at which our theory is based on. Perhaps maybe we would have a breakthrough that we have some similar ideas or concept or theories on that level, but it wouldn't be as unpredictable as when Einstein or those quantum mechanic Niels Bohr that those collectively came up with. Like quantum mechanics is such a big thing, right? Even though everything we will find out, the theory we will find out has to become somewhat consistent with relativity and quantum mechanics.
I think this kind of goes back to an earlier conversation we had many episodes ago about an article
Oh,
that was suggested to us saying that the age of discovery is long past. And I think it was maybe 1965 was kind of the defining year, or at least the cutoff year, where before 1965, there were discoveries happening what seemed like every year or every month, whereas now it's very long, drawn out discoveries that are essentially more statistics than anything else, at least in experimental physics, which we see with the G minus 2 or with the Higgs boson. So I think this kind of goes back to that conversation of, well, there has definitely been a change, and does that hold
yeah,
true?
and last episode we talked about Lev Landau for our story, who was this quote unquote modern day physicist. I mean, not he's not alive anymore, so he's not a modern physicist, but he was in around 1950s plus or minus however many years. But these people, a lot of these big scientists and like Einstein and all them, they were making completely physics life changing discoveries every year it seems, and now it's the low hanging fruit analogy Patrick had, where there's just bigger things to discover, and then you refine what you discover over time. So there's less like big changes in our field. Um, Although there's still plenty of things to discover out there, but we can talk about that another time.
Well, I think in that episode way back, I made a case for modern discovery that, those Einstein or, old school physics couldn't dream of discovering these at all. So in a way, objectively to me, I still think it's a bigger discovery. But in terms of human experience, it's different because everyone start off as zero, right? Like, well, some, in terms of knowledge, you're a baby, you don't know. So in terms of that, it feels insignificant in modern discovery compared to more fundamental discovery back in the days. But objectively, it's just it's a stepping stone. There are stepping stones to, in a way, a bigger discovery that change, maybe not as fundamental change, but actually delve us way deeper into this rabbit hole of science. So objectively, to me, modern discovery is still much bigger, but not in terms of human experience. It's not how we experience it, but I think in terms of like if someone were to put out a tapestry of human discovery, I would still say the one that actually make us much deeper understanding is the modern discovery, because those just lay the foundation as to how to think about the world. Then you actually go to specifics of like, oh, neutrino oscillations, like that's mind blowing, right? But it's not as fundamental. But doesn't mean it doesn't dig deeper. I still think it dig deeper into our understanding, because you need those stepping stone to have the slightest glimpse onto how to rationalize those ideas.
It's funny too that like even these huge ideas that we know how they work very well today, we still don't really understand them, like quantum mechanics and relativity, and we still don't really know how. Well, we know how it works, but we don't know like fundamentally what is the real physical interpretation. There's all these different ones. But I want to come back to Oppenheimer because I thought it was so funny that you talked about how like in the movie, he's waking up in the middle of the night, sweating, trying to like understand these physics concepts. And maybe I wasn't sweating that hard, but 2 days ago I woke up in the middle of the night because I couldn't stop thinking about this differential equation that's relevant in my research, and I was like, oh, it has two solutions, and one of them's converging and one diverges, and how the heck do you derive the asymptotics of the diverging one? I couldn't figure it out, and then in the middle of the night I woke up realizing what I had to do, and I like ran to my desk and just wrote down quickly like how to do it in 5 minutes, and then I went back to bed. And so when I woke up, I had like this nice note which was kind of incoherent because I was half asleep, but I got the gist of it.
Well, I think here's my take on scientific discovery. Maybe some people would disagree because people like to think that science and math and stuff, the process and everything is super logical or logic based. Everything has a reason, if A, then B, but that's not how we discover things. So to me, we delve into imagination a lot. You imagine. There's a lot of creativity that goes into it. Even though we try to devise these strategy and system to solve problem, but true discovery doesn't come from picking. There's certain things come from picking pieces apart and figure out how it works and how things are connected. But a lot of large or significant important discoveries are all imaginative, right? They're all creative concepts that to me doesn't come from picking apart pieces of the world, but you just see it. And I think a lot of mathematicians would do the same thing. Like Ramanujan, for example, he's like, well, it's just true. You just see it. Or we see might not be the correct phrasing, but there is the element of creativity to it, which well, I would just put this word out, but like in my opinion, is it's a way to take a peek into the what in, we call the divine, or the realm of the abstract, and that is not logical. That's my my little hot take on it. There's this creative requirement that's needed, even though you still need logic, faculty of logic, to figure out equations and how to properly describe it. But the process is discovery. Like you said, you woke up in a dream. That's not like you're picking apart the equation. It just
So
comes.
I have a really good example of creativity creating a field of physics. Because, well, I'm sure there's many good examples, but the physicist Bill Unruh, which I've talked about probably a bunch before, and I probably said that I talked about him a bunch before a bunch of times. But Bill Unruh is this Canadian physicist, and he was like a, a general relativity, quantum gravity kind of guy back in like the 70s or 80s. I mean, he's still alive today. I met him actually, which was kind of cool. But he's famous for this thing called the Unruh effect. But he also created the field of physics that I study, which is analog gravity. And I talked about that in the first episode and many episodes since. But he came up with it kind of by accident because he had to give a public lecture so to people who weren't necessarily physicists, and he was trying. This was when black holes were kind of like, they weren't brand new because it was the 60s 70s, um but they were new to the public. A lot of people in the public didn't have any idea what these were, how they worked, and he was trying to come up with an analogy about how do I describe a black hole to someone who doesn't know any physics. And the way he did it was he imagined a waterfall with fish in it, where if the fish are on the top of the waterfall in the river, they're able to swim up there, and they can talk to each other and everything's fine. But if, say, one fish accidentally gets swept over the edge of the waterfall, if he tries to scream for help to his friends at the top, the sound waves get pulled down the waterfall faster. They can travel up it. And that was the analogy he used. And a few years later, he was kind of thinking like, oh, that's kind of like a black hole. Well, he knew it was like a black hole, but for sound waves, where these sound waves in the fall they're swept away with the fish, and in the top of the river, they're able to escape the waterfall. It's like if you're in a boat at the top of the waterfall, if you're paddling up river, you're fine, but if you go over the edge of the fall, you're not going to be able to cartoon paddle back up the waterfall. So years later, can't remember how many, but like 5 or so years later, maybe closer to 10, somewhere in there, he kind of he had to teach a course on fluid mechanics, which he'd never taught before. So he was trying to teach himself fluid mechanics so he could teach this course. And he said, oh, I remember this like water analogy that I use for black holes. Like, I wonder if I take the Navier-Stokes equations and linearize them and do it for a specific flow, like a waterfall, like, what do I find? And he found exactly something that looks like Hawking's prediction for black holes. So he discovered that you could observe Hawking radiation in a fluid, or analog Hawking radiation, just through this fun thought experiment. And he happened to be forced to teach a class he didn't know about. So, yeah, it's pretty cool.
I feel I heard that from you a couple of times.
You probably did.
It's a good story.
I might have told it before in this podcast. I don't think I talked about it in the first episode we did, but maybe.
To be fair, there's like 55 of them.
Yeah.
So for now, I want to lead the conversation back to wrap up Oppenheimer, and if anyone else have also like last comments on Oppenheimer. It actually reminds me of when I was younger. I used to have a mission. When I didn't know as much about the world and science, and a lot of things that really confused me, made me anxious, was having too many choices. Because when we were young, I was young, I realized I'm really good at science, I'm pretty good at physics, and I'm relatively okay at math. And I had a mission. It's like, okay, here's my goal in life when I was like, 15. Like, well, I'm gonna do physics and figuring out how the world works. And I made that my like my one thing that I do. I'm really passionate about it. I just specialize. And then growing up, I just starting see more of the world. The internet played a huge role in seeing other lifestyles, how other culture live, how other people, how you guys live was unheard of. Like for me growing up across the world, right? It's just completely different. And it opens me up to, in a way, maybe it opens me up to like this too many options of lifestyles, of things that could do. And I think for quite some period of time, I lost this sense of purpose that just made me more generalized. Actually, just I want to learn about, maybe I want to learn about more about this part of art, which is a good thing for me. Philosophy, or play sports I never played before, or watch sports I never would have watched growing up, or all these different things to in a way, in some sense, distract me from my original goal. But I have enjoyed it thoroughly. Like, it's not like it's bad. It feels pretty good. But my life would have been so different if I was in that well of just doing physics, right? And I think what happened in the modern days is that we all have this different information coming in of different lifestyles, how to live, how to actually have a good life that's different than just specialize, do physics, figure this out. And I'm not claiming it's good or bad, right? But that movie really reminds me of why, in the first place, I was interested in physics. I used to have the same mentality of, hey, we are human. Here's a mission to figure out this physical world. And it's not just me. There are many, many other physicists trying to figure it out. It's a collective effort, it's a noble cause, and it should be. And it got lost at some point along the way, but that movie really reminded me of why I did it in the first place, and in a way reignites a little, fire in me that's like, this is why I want to do physics. So that's probably my concluding remarks on the Oppenheimer. Let's see if you guys have more.
Well, before my concluding remarks is that, yeah, your comment just reminded me about how I feel a little bit better, not being one of these scientists who made a new life-changing discovery every week because of how much we know about the world now. Like, I think these old school physicists, they were super hyper focused on physics and not much else. I mean, of course, that's not true. There are many examples of that not being true, but in general, it was more true, I think, where today, like so many physicists I talk to and meet, we have other things. We have hobbies, we're interested in other things. And of course, older school physicists did too, but they had less distractions, I find. The internet's great, but it's also dangerous in a lot of ways. I can very easily sink an hour into just scrolling through Instagram reels by accident.
Well, I think one of the things too that that generation, the world is very dark. What I meant by that is in terms of information. I remember growing up, right, when you're 8 years old, or well, when the internet wasn't as prominent. Your community, your world is just the people around you, and the rest you don't know. Like, you don't know at all. I didn't know about other countries. I didn't know about anything that wasn't taught to me. And now it's so different. You growing up know that other countries exist. People who don't look like you exist, and that's it. In a way, it's a new concept for a lot of people. And even to me, when I came to Canada for the first time, like, oh my god, there are people that don't look like me, or I mean, there are a lot of people who don't look like me, but they're completely different. Like Liam, for example. Like, I was like, that human exists, and it was it's shocking in a way. And but to me, it's a very human experience, right? Like who could say that not everybody grows up in a multicultural, multiracial place, right? It's just when you grow up in a like more homogenous place, you're like, oh my god, there are human beings that can think and can rationalize, and we can get along, we can love each other, we can be friends, we can do stuff that like to make us human beings, that not just your community, that the rest is enemies and this dark hostile world. So well, I just want to put it out there.
That's so funny. I saw Liam and thought, can't possibly be people this white. But yeah, yeah, exactly. With the internet and how small the world is now, there's just so many more incredible things that your attention and interest are divided between. So people are like more of jack of all trades when it comes to knowledge now than they were back then. That's my hypothesis, is that yeah, people just they spend their time not as focused on a single subject and divided amongst more, which is a good thing. But it also means that the average person is not as specialized as they might have once used to be, at least in the physics community. I mean, I don't know, but speculating.
I mean, just as final thoughts on Oppenheimer, I think it made me nostalgic for a time in which I was not alive, in the sense of to collaborate with someone. Today, we just do it over Zoom. We have meetings over Zoom, which, to be fair, is somewhat more recent. But in the time of when Oppenheimer went to Cambridge, they said, "Oh, you don't like experiments? Go to Germany." And he did. He studied in, I think, Göttingen. And so he was able to meet people like Niels Bohr and collaborate with them and work with them. And then the whole Manhattan Project was bringing truly people from all over the world, or at least Europe and America, to work on this one project and collaborate. And it makes me nostalgic for that time where it was, I guess, more complicated to collaborate. But when you did, it was, I guess, the meeting of great minds, but also made me miss our undergraduate because that's what we did for, I guess, about 2 or 3 years was we were all in the same room. We were all collaborating together. And if one of us was struggling, the others would be like, okay, this is what's going on. Or if we were all struggling, it was great because we would spend hours at a whiteboard just trying to figure out, okay, how do we solve this problem from quantum mechanics or thermodynamics or something like that? And so I think that's something that I missed as being part of a large collaboration in particle physics where we had a small collaboration with 40 to 60 people, and you don't get that necessarily where you're constantly bouncing ideas off of each other. And of course, the pandemic didn't help either, where it was, say, one person working in a lab for 12 hours straight for many days in a row. And so you get that kind of isolated feeling, despite being a part of collaboration. Whereas seeing that where you were forced together and you had to work together and bounce ideas off of each other, and experimentalists and theorists working so closely together, it was, and discovering new things, it was, yeah, a different time than our very connected world where we can connect with anyone instantly if we want to, anywhere in the world. And uh, it's, while that does remove barriers, it also, I don't know, I feel like puts up different sets of
It definitely
barriers.
depends on what you're doing. Like, what is the scope of your research and how are you going about it? Because you get these huge, like, even when you said 60 people in particle physics, that's like a pretty small, or an experimental particle physics, 60 people is a very small kind of collaboration. And you can get lost in those 60 people. But I've been very fortunate that I actually, oh, sorry.
Look at the particle physics paper.
Yeah.
Look how many
If
authors
you,
there are. So
yeah,
like you
even
know,
Yeah, particle, like, I think one of our old profs, he was on a few papers that were related to things CERN did in this Babar experiment you mentioned before. But the papers had like 50 authors on them and stuff, where the papers I'm involved with have like 1 to 4 maybe.
Yeah, I wouldn't lie. I think particle physics may have broke me, and uh, I wouldn't get into that, but it was, it sounds like a different experience than what other people, and I do question if, say, I'd been slightly better at math and gone in a different direction, if I would still be in physics. So it's interesting, and a caution to those interested in entering particle physics in terms of the experimental side,
Yeah,
be
well,
careful.
you're not the only person I've heard who's had a bad time with experimental particle physics. And I don't think it's necessarily, I think it's just a very intense, you have a million meetings, they expect a lot out of you, you have deadlines. It's a lot more like a proper job, whereas other branches of science, and well, maybe not science, but branches of physics are like you're a free thinker and a researcher. But I feel like, yes, other parts,
Science too.
but I feel like they drive you harder in experimental particle physics.
well, I think okay. I just attended one of the PhD defense on when he did like experimental particle physics, and he did a great job. But one of my thing that was when I was watching it, I was like, where are the results? because the entire PhD was building this huge, I mean, collaborative um, device that to detect whatever dark matter and stuff, right? Like, and it's you are a part of the big machine. So it might take 10, 20 years until you get results from the machine. And but that's your PhD. Like try to figure out how this part of this huge device work and making sure that the data is correct, getting rid of the noises and uncertainties, and make sure that you can actually detect what you want to detect. But maybe I'm more used to in more condensed matter and stuff, right? Like there's more like, okay, what do you find? And I think in maybe a little bit in astronomy too, we have that more instrumental physics rather than like try to get the results, which makes sense. It's just a nature of the field, right? Like because in if every PhD student in particle physics had to find like let's say a new particle, a new violation, nobody would get a PhD. And because it's about building expertise so you can work in those environments, which I think they did very well. But in terms of like the material, it's quite a different thing, right? And I understand why it can be frustrating to some people. Like, man, I just want to see something come out of my device. I spent 4 years of my life trying to build a device, and it's not going to be ready for the next 10 years. Why is it not frustrating, right? But for some people, it's rewarding too because you're part of the collective effort to build this for humanity, not just for you, not just for me, but not for just for your community. It's for mankind. So I can see argument of both sides. So now it depends on what you want to do, right? Are you choosing that or the other way around? And a lot of people would be discouraged from the fact that there's no immediate results. And some people are more attuned to like, hey, you know what? I can wait. And if I'm part of this big machine that give amazing results, I'm okay with that. And it's just different choices in life depending on your personalities.
I think a lot of it is not just results, but recognition, because when you work on these huge scale experiments with hundreds and hundreds of physicists, your PhD thesis might be to make like one part of a 2,000 part machine. And and they're all really hard to do. These experiments are extremely difficult, which is why they have so many people. But when I think about like CERN, these huge particle collider, LIGO, the gravitational wave interferometer, the that I forget what it's called, but it's the one that detected neutrinos and won the 2015 Nobel Prize. Um, No Lab.
Snow Lab.
Yeah,
Yes,
but
Snow Lab. So I was gonna mention that too because they gave it to Art McDonald's,
yeah,
right? Like
that's that.
the other one in Japan, but it's not. It's just him, right? It's like literally like hundreds of
Mhm.
people that collaborate on that, right? So even though he was overseer or overseeing everything, so the recognition goes to him and his team, of course. But I know many people who part with Snow and Snow Plus, and now Snow Plus for Dark Matter. So there's a different in terms of like I don't say recognition, but it's just a part of the let's go the nature of the work. Like there are so
Yeah.
many people, and it's a huge
But
project you need
that's
to
the
build.
exact point I was trying to get, is that these huge scale physics experiments, like you have to be prepared to, even though you'll get recognition in the citations, you're not going to get like public recognition or even amongst the larger physics community, because Art McDonald, 2015 Nobel Prize, that's Snow Lab, but hundreds of people worked on that thing, right? And I don't know their names, I know his name. In fact, he came to our old undergrad university and gave a talk on it once. We were all there, I think. So it's that's part of it too, I think. Whereas as a theorist, or even the condensed matter experimentalists, they have much smaller scale experiments with less people working on them. They get more of that. They get to see faster results, like you said, Feely, and they get to get their names on citations and not have like 100 names on a single paper, right? So, and like me as a theorist, yeah, if my group, I don't have to worry about that. Like if I publish something, I don't have to worry about getting lost because I'm only one of the 2 or 3 authors. And I feel like I have much more, as a theorist at least, much more of that Oppenheimer-like experience where there's only a few people in my group. I'm not working with a huge collaboration, and we'll run into the hallway and start talking, and then we'll run into a room and start writing stuff on a chalkboard. It's like, oh, we had this idea that even though we just bumped into each other in a hallway, or we'll go on walks through the woods and discuss like ideas and different things about the world as well. And we'll have group meetings and we're all like standing around a chalkboard, like writing and talking and disagreeing or agreeing or arguing and stuff. And it's, definitely wouldn't, maybe you'll experience it in some places, but I feel like it's way harder to do every day when you have these huge groups and these huge international collaborations. I mean, I have international collaborations, but they're definitely smaller scale.
Just two things to add on to that. And one area that we haven't really talked about is computational physics, or just computation, because one person that comes to mind when thinking about, oh, this one person, he does quite a lot of work and has a very large impact on his subject area, is Dr. Peter Poole, who was a former professor of ours. If you say his name around anyone that studies water, they'll almost definitely know who he is, or other computational people will know who he is, just because of the impact that this one person has had. And in the case of him, he has many collaborators, and he is an incredibly humble and generous person. But still, the impact that especially people who do computations have is incredible, because it can just be one person working at a computer trying to figure things out. Another person who comes to mind from my university is Dr. Bruce Sutherland, who studies atmospheric waves and gravity waves and a whole bunch of different types of waves within the Earth that happen naturally. And he has also huge name recognition. And again, he's not alone in his work, but still just this one person. Whereas now in particle physics, we do have like one person like Art McDonald, who is getting the Nobel Prize, but so many people behind them, like thousands. And for something like the Higgs boson, that's 5,000 people who had a PhD or above were cited. Not really anyone who was doing their master's or undergraduate that helped work, just people who were doctors and above. And the other thing that I want to say to that is, after having left particle physics and going into a different branch of science, that's my experience generally agrees with Liam, where we'll get an idea, we'll run to a whiteboard, write it out, test it out. We do a lot of data analysis, so we'll test it out quickly, see if it works after a day or two of running something, which is exciting and rewarding because you do get results. Unlike the person that Pheely was discussing, who he worked for many years on the Snow Plus project, but still didn't, I believe it was Snow Plus, but still didn't have any results from that project itself. While he did have results from different contributions to it, there's okay, here is a neutrino detector that we've developed that's even more sensitive than the original snow detector.
Oh, what I was going to say. But to wrap up Oppenheimer, well, maybe not wrap it up because we've said that a few times now, but I thought it was good. It was entertaining. It was a good documentary style film. As a physicist, it obviously resonated a lot with me. But I definitely had more fun watching the Barbie movie. I cannot lie about that.
Well, I think there's a lot of cameos in Oppenheimer's that, like, if you know, like Feynman, for example, they didn't mention his name at all, right? But when you see it,
every
like,
time they
that's
had.
Feynman. And I'm surprised that, like, because I've seen some of the boys, like the show, I was like, you picked that guy for Feynman, but I can see it. But I think one other thing I want to say, which I start to forget because stuff, but is that particle physics, and as a bit of also, I think quite a significant part of astronomy is data science, right? Like dealing with large data, filtering it, taking out noises, analysis. And to me, before, I mean, up until a few years ago, I thought it was like, well, that's not physics. However, it actually changed my mind when I got to graduate school, when I actually get to know astronomers and particle physicists who deal with large data. Like, because if you don't know physics, you don't have a clue how to process those data because you don't know what they mean. They're just numbers. But if you know the physics, You actually like, oh, this is interferometry data. And these are how it works. These are the spectral profile. These are how it works. These are the Fourier transforms. And these are how it works. And it's a niche. I think in the computer science perspective, it's probably like a niche way to look at data, right? Because like it's not just some unstructured data. There are rhymes and reason behind those data. And you have to know physics. Sometimes you have to know it very well to be able to use the data to effectively filter those data. And so now I changed my mind actually. It's like, wow, that's is a physics that manifests itself in a different perspective, in a different regime. That's like, this is how you use understanding of physics to maybe experimentally, well, it's how to say, like, to provide, to create discoveries that are otherwise could not be done through theory. Like, because there's so much large data that people like, well, how do you form new theories? Like, you have to have some kind of empirical evidence that guide your logic, right? Like, oh, your imagination is like, oh, this is how the world works. And who would process those data? Like, well, people who know the fundamental physics really well and know how the data should be presented, how it should look like, how the stars should be shaped, how the black holes should be shaped. People who analyze black hole data, they have to know the predictions of how accretion disks around black holes look like. If you don't, you just process these literally petabytes or even more of data like in the blind. So I actually changed my mind a lot about astronomers because I usually like to throw shades at astronomers. Just don't tell our former guests, but our mutual friend who went to undergrad with us would know that I like to say astrology a lot. Um, but now I'm starting to get it. I always know it's important, but I just didn't understand why it's like very physicsy. And I was helping one of our former guests. She just defended her master defense. Congratulations to her. And it was like, wow, there's a lot of physics in this. Not just data analysis. You have to know about formation of stars. You have to know about how, like, a little bit of quantum mechanics, interferometry, about light matter interaction, about electromagnetism. It's not just data analysis. It's based on physics, which is really cool. But I would never do that.
It's hard stuff. Patrick, you did a lot of data analysis at one point for your particle physics undergraduate work and maybe even your master's work. But yeah, like I never thought about that before, Pheely, but you're right. Like if you have a bunch of data, what do you do with it? Well, you need to know what to look for and how to ignore the irrelevant data. And you need to know the science to do that.
Yeah, I mean, from a particle physics perspective, there is a large amount of physics that has to go into it. Like, even just thinking about my master's thesis, I think it was 6 chapters, and only 2 of those chapters relate to data and its analysis. I think 2 or 3 chapters was just background, like, okay, here's an introduction, and then here's dark matter, here's the physics behind dark matter, here are the equations that describe how it would interact. And so you have to know all of that. And then also your statistics and your data analysis. Because, like you said, for the undergrad, it was essentially just sorting through data. You have to know which cuts to make, what's unphysical, what would be physically irrelevant to the data that you're looking for. And I guess in collider physics, especially for that experiment, it was a bit easier because it was just an electron and a positron colliding it. Asymmetric energies, but still high energies. But because it was just an electron and a positron, it was a relatively easy interaction. Whereas for searching for something like dark matter, where you have this detector and then it's filled with different gases, and then you have the physics of the detector that you have to understand, as well as the physics of how that dark matter particle would interact should it exist, and then also the background effects. So there's a lot that you have to understand and then cut out of the data. And I mean, that's one thing that was a struggle with the collaboration. Maybe not necessarily a struggle, but an issue that was being worked on was what data can we remove from the detector, what data should be removed, what are the effects of everything to consider. So it's really interesting because a lot of experimental physics seems like data analysis, when in reality you have to know the physics of it. And even in my new program, there is a lot of data analysis. In fact, that's mostly it. But you also still have to understand the physics. Like, I worked with the German Space Agency and people from there and went to go visit. And the person I talked to had a physics background, but was working on atmospheric corrections, which are incredibly complicated for optical instruments or different types of sensors in space because the atmosphere is ever changing. It's a chaotic system. And so you do your best, and you have these complex differential equations that need to be solved, and then you can apply that to data. But there is, a lot of physics that needs to go into data analysis, or just a lot of thought and mathematics and effort that goes behind data analysis so that you can just say, okay, we trust this result. Here's 10 pages why. Here's our result. Here's how it matters.
All right. I think I want to move the topics maybe a little bit of a detour. Just go see a seaside view that's not very physicsy, and because I kind of want to chat a little bit on more the other people aspect of being scientists and physicists. And I just realized myself, maybe I'm just typical physicist, maybe, but I it's I don't. It's hard to judge if you're part of the norm or not. But most of the time, I don't feel like I belong to the typical human being in general. I don't know if you guys would agree, but I think I have very strange way to do certain things, and I'm kind of a strange guy in per se, and I'm kind of self aware of that, and I embrace that from time to time because even though growing up back home, I'm not kind of normal either. I'm pretty what's it called, eccentric, and
You're not like the other boys.
Yeah, you're quirky.
yeah, quirky. I don't know that the word quirky has different connotations depending on how you say it, right? It can be negative connotation, it can be positive. Like, oh, this guy is quirky. Like, this guy's quirky. That's different. But I find I'm just trying to be myself. What does that mean, right? Like, because I realize when people grow up, you start to imitate people you idolize, right? Like, and it's like you try to be whoever you see that you think is cool, and especially young men, right? And that's all the time. And I don't really know. I don't idolize or glorify people much either. It just came up to be you know, I'm not really sure what I'm doing either. I'm just trying to be or behave what I think is right, and I'm not. like, I don't want to say just and righteous, but as the best person I can be, and sometimes it's just like not really don't really follow what people like read the norm of the world per se. I just do what I do, and I think that's the benefit of having freedom, I guess, of being able to act according to your own will without being burdened by this pressure from society, from, well, everybody's pressured by society, including me. But um, to be able to express yourself the way you intend to without being judged or condemned. I think that's very important that I find in the Western world. I'm not saying, well, it's a little more restricted when I was growing up back home, but really coming here, I really felt like a different person. So it's kind of strange to think about it from time to time. The person who I am now, when I think about it, it's like, yeah, maybe I'm not as like normal as other people.
Yeah, I definitely think moving to another country where things are different and you have no one is there with you, like you can just be someone different because there's no expectations or anything, right? Like you can do kind of whatever you want within reason. And the other thing too is that people do a lot of changing between, high school and whatever age we are now, like after university, or I'm 26, so between 18 and 26, you change a lot in that time. So your opinions change, the way you do things change, the way you think changes.
Well, and what I find is also like, that's why we call those like formative years, right? When you start from like let's say 18 to 25, you start to find yourself. It's kind of strange too because when I think about it, people, the person I was 2 years ago, I just felt far removed from who I
Yeah,
am now. Even though those 2 years, I was still doing grad school, right? Like, but there's so many tumultuous things in my life that changed my thinking completely. Like it's just I feel like a different person, and I think that's one of the reason why even though like seniority comes into play when you see other people maybe 1 or 2 years older than you, but when you're 20, they just feel much more mature. Even it's different if I'm like, like 26, 27, see someone do 28, it's like, well, maybe not that much, right? But there's such a drastic change in those formative years. And I noticed that like, oh, heavily. Even on me, I feel, and I think it's a good thing because it means you're growing, right? You're growing every year. And maybe my perspective would shift completely next year. Who knows? But I hope not, because I think I have pretty good arguments and foundation of why I think this way, but things could change.
I would just like to point out that we have now spent as much time in grad school as we did in our undergraduate degree, which is wild to think about because, I mean, the 4 years doing an undergraduate degree for the three of us seemed like quite a long time. Of course, we were learning a lot and experiencing a lot and also meeting each other. But it seems that the past 4 years have definitely gone very differently. And I agree with you, Pheely. Even thinking back to 2 years ago, I'm a very different person. And 4 years ago, who was that guy? I don't recognize who that was. And the fact that we've been in university for 8 years at this point and we still have time to go is really wild to think about.
wild is one word to describe it. But I also think, so the 4 years in undergrad felt like a very long time, and it was a really good time. But the 4 years we've had in grad school, 2 to 3 of, well, I'm not sure how many. I'm gonna say 2 and a bit years were during COVID, right? Like things were completely different. So in my mind, even though I've been here for 4 years at McMaster, I've only been here for about 1 to 2 years, so it feels a lot shorter. I didn't have there was like 2 years where I was just at home doing things. It was a very different experience, and it's definitely changed the way things work now. But it was different.
So, reflecting on those 8 years, or even the past 4 years, or whatever time period you like, I guess from all of our experiences as researchers and scientists and students, what has been your least favorite part?
Hmm.
Yeah, well, we'll get into the
The
positives. We'll start with the negative, but
Well,
out of everything, what is
you
your
know what?
least favorite part?
Yeah, let's do this instead. Because I used to do this with my friend. I still used to do it from time to time. We call it two roses and a thorn. And you guys have done that. Um, so in the past 8 years, basically do two things that are positive and one thing that's negative. I think it's a really fun thing to do because instead of saying negative or this is like it's a little game. I don't know why. I don't know who started in my group of friends. It was really fun, and it was more fun when someone came up and it's like just say three bad things. Like, what do you
well,
mean?
it's like the positivity sandwich. You say something good, something negative, and then something good, and it like softens the blow of the negative thing.
So, I guess to you guys and to me, but what's one of your favorite parts of being a researcher, a scientist, or a student, or all three?
Well, I'll go first. Really, I think my favorite, well, not favorite, but like the best thing is that because like not many people have the opportunity to realize their dream. Even though I don't know if this is my dream, but it's pretty close, right? Like being a scientist and is a niche career. It's not like it's a career that is not lucrative career. Compared to other like high end lucrative career. Like scientist is not known as to make millions of dollars, right? Like no, it's a professorship, for example, is not. But not many people have the opportunity. I'm so grateful for that. That I'm able to walk this path on my own volition, and well, with support from my family and friends, of course. But that's one thing that over the past 8 year or so has been no less of a blessing that I am able to do this at all. Like, I used to think that I had to be an engineer or go to be a doctor to be successful in life. And the fact that I'm now on this path is just unbelievable. If I were to tell myself at 10 years old that I'm going to be doing this across the world, I wouldn't believe it, right? In a way, it's such a um, great thing that happened to me. So to me, in the past 8 year, objectively, if you look holistically, is an amazing thing.
Uh, I guess for me, I think one of my favorite parts has been the people, because doing research and being a student has allowed me to meet a whole lot of people, more than I would have ever dreamed of. And with those people, finding people who, I guess, were in my niche and really had similar ideas and similar thoughts. So, for example, when Pheely and I did a radio show that kind of inspired this podcast, that was a really fun thing to do. And we had some interesting discussions live on air instead of pre recorded. Or finding Liam, who also bagpipes, and the fact that there were two bagpiping physicists at the same university was pretty cool. And just the other people that were in our undergraduate as well, finding that community and that group of people who we suffered together, but we also succeeded together, and continuing to remain in contact to this day, and do things like a podcast or have, as of now, online meetups or even in-person meetups for the people in Ontario. But it's also let me meet some of my heroes. Like I was able to meet Art McDonald, which was super cool. Was able to shake his hand and say hello and talk to him for a little bit, or meet people who've worked with the Atlas experiment, which was my dream as a kid. And now I'm meeting people who work at space agencies and talking to people who have jobs that I could only dream of as a kid, but now are within the realm of possibility. Like what you said, Pheely. Like there's that kind of childhood dream of doing our dream jobs, and we get to do them, and there's a whole bunch of open doors because of the people we meet, and we see a job or meet a person and we're like, oh, that's cool. Let's go that way. And now let's go this way after meeting another person. So I think, yeah, the people and the community that I've been involved in have definitely been a major positive.
Well, I think before I pass it to Liam, it's like, whoa, yeah, I just realized like not many people get to meet like physics Nobel laureates, and we met two, right? Like Art and Donna Strickland, which is like two is more than zero, and that's a lot compared to not many people get to meet one. So that's great.
Yeah, like I think I've met 3 or 4 now actually. Frank Wilczek or something like that. I think I'm getting his name wrong, but I mean, I met him in a Zoom call if that counts. I asked him a question. And he
No,
answered. Um,
sure.
I
Give us a
asked
rose.
Penrose a question too. Oh,
Give
my
us a
rose.
rose.
So you guys stole them, but I have a third one that which is different to keep things interesting. So over the last 8 years, I think one of my favorite things that's happened is the way I think has changed dramatically, for the better. So I really got into physics out of all the sciences because I just like knowing things. And I know you always hear physicists talk about, oh, it's like the discovery that's the exciting part, and it's the journey you take to learn things, which is the best part, which is true. Like that moment where you realize something new is very, it feeds those chemicals to your brain. It makes you happy. But also, part of me just likes knowing. I just don't want to not know about how something works. And the way I think about things has changed so much. Like I'll be walking down the street and I'll see some weird wave thing in a puddle, or I'll see some optical phenomenon in the sky or something, and I can look at it now and just think like, oh, I wonder what's causing that, and I can break it down into simpler problems in my head and come to a conclusion. Like I was on a plane once, and I have this one of my hobbies now is I look up, I try and find atmospheric optical phenomena. So things like rainbows that I've become kind of obsessed with. Oh my god, my cat is going ballistic right now. He's found a toy and he's having a good time. One of his little favorite like mouse toys he's throwing around. But anyway, rainbows and atmospheric optical phenomena, things like sundogs and ice halos. I'm obsessed with them. And I was on a plane and I was looking out the window because, of course, I was keeping my eye open for some plane rainbows and things. And I saw this giant white patch that was just following the plane. It was moving with the plane. And I kind of thought, is it just a reflection? And then off the plane, I was like, oh no, it's in the same spot and the plane's moving. So if it was a reflection off the plane, they would move with the plane, the change with the shape as the plane moved. So I was like, okay, maybe it's some atmospheric optical thing. Like that'd be really cool. And I thought, oh, what could cause this? I'm like, it looks like a mirror. It's just reflecting the sun off the bottom of the clouds up into the plane. So I thought, okay, there's ice crystals in that cloud and they have to be roughly flat to be acting like a mirror. And I went home and I looked it up, and what do you know? This thing's called a sunspot, and it's caused by hexagonal ice crystals floating down roughly flatly, so they act like a big mirror. And that's pretty rewarding to me, is when I see something in nature and I kind of apply. I come at it from like a very scientific point of view. The way I think has changed. I think, could it be this? And then I go through the reasons why it could or couldn't be this. And if not, then I kind of toss it away. But if there's a possibility, then I put it in the back of my head and I move on to some, could it be this other possibility? And I move on like that. So I really like how the way I think has changed dramatically.
Well, okay. For next, I'll put a thorn in between, right? So I think the bad part about the past 8 year is that I just okay, maybe it's just my personal thing. Oh, it is personal, but I just realized how alone I am. In not in terms of I'm graced with good friends and family that been around, but in terms of my mind, that just I'm an individual. I spend a lot of time in my own head, and like I said before, I just feel like I'm a little eccentric, right? I'm different, and knowing and you're different, even though you realize that people who are also different and probably have the same thoughts as you, but also I'm pretty introverted. Well, some people might disagree, but I see myself as an introvert because I like to be alone from time to time. I need to recharge by being alone. I don't get it. It isn't a cost of energy for me to interact with people, even though I like interact with people, but it's really tiring. And I just realized that, like, oh my God, sometimes I just rather be alone and leave myself with like, to my own thoughts is sometimes dangerous for me because I just go on this terrible rabbit hole and of thoughts and trying to find meaning to things, trying to find um, you know why things happen and what's the proper way to do things, and it's it's a gift and a curse, right? Like it's a blessing and a curse. What people say, like sometimes it works really well. It allowed me to be analytical. It allowed me to be, involved in these complex thoughts and thinking. But in a way, it torments me a lot. Sometimes I couldn't sleep. Sometimes I couldn't eat because of it. And it's it's a good problem to have in a way, right? Because in a way it exists in my mind, but it kind of affects my kind of mental health a little bit. I don't like think about it that way. So that's like my biggest thorn is like this type of investigation in my head has plagued me with sometimes terrible solutions, terrible thoughts, maybe nihilism, which most of the time I counteract it, and these negative thoughts that can be expanded as complex as the scientific regime that I've been involved with, but you could do that, do the same analysis to like terrible thoughts, and it's not fun. So I think part of the 8 years that been doing physics, that's part of it. Like, you have like maybe not so good of a thought, I mean, in terms of like, negative thoughts, and you expand on that idea in the same level of complexity you expand on physics. And you realize how much terrible impacts you could do to the world if you keep that line of questioning or that line of logic going. I was like, wow, I mean, I think people could do a lot of harm to the world. Like smart people could do a lot of harm to the world if they put their mind to. And that's actually like a profound realization to me that actually people are good. Because if people are actually bad, like we have been burned to the ground like 1,000 years ago, or literally like 2 or 3 thousand years ago. So, like when you follow the line questioning, it's tough. But part of me like it, but I put it at a thorn because it's really hard on your health.
Yeah, that was deep. Um, but yeah, this isn't my thorn yet. I'll come to that, but I agree. Like, I guess it was one of them is that coming to the realization, because I guess when you're younger, you're just like hyped. You're like, science is the future, science, 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 and then you realize that like maybe we shouldn't be like the atom bomb, right? Like, it wasn't a good invention, in my opinion. And well, yeah, obviously it wasn't, but maybe you shouldn't do some science just for the sake of doing it, because eventually it'll be made into something bad. And that's kind of like one of these realizations you have the more you do science. You're like, oh, like maybe trying to come up with how to stop DNA from decaying and creating longer lives, like people living for thousands of years. Maybe that's not such a good thing. It's not natural. Or maybe we shouldn't be creating big super weapons with physics developments and all kinds of things.
Well, I actually think it's completely natural that we devised catastrophic weapons, and
Oh,
I think it's a good thing because actually I
whoa,
think it's an
whoa.
eventuality. Because it's gonna happen at some point, and better have a person with moral virtues have it than a person without. Well, there's debate on that, right? But to me, it's already happened, and I'm not trying to justify what if it's good or bad. I'm saying it's eventuality. We're gonna discover it at some point. Like it's inevitable. It and it's not that hard to think about it too, because remember in Oppenheimer, the first thing when people say like, "Oh, fission can happen," what do they think of? Like the bomb. Not just like it's like the intuitive thing. If the chain reaction keep going, it just makes sense, right? And human conflict has been encoded into us, like like conflicts, like it's not the world for the most parts of history has been a bloody and dark place. So I'm not surprised that it became a weapon, and is to me is necessary. But we can agree to
Well, yeah, I'm
disagree.
not surprised, but I'm just saying it's like it was a sad realization that, well, maybe not realization, but sad acceptance of the fact that, science can be used for bad things. But that wasn't my thorn anyway. That was just, I guess it is.
I mean, science have been used as instruments of war almost since the beginning of science. I mean, look at the lenses that burn ships, right? Like
Oh, the
it was just and all weapons. Like how you think people work out how to build crossbows,
yeah,
cannons,
yeah.
guns?
But
It's yeah,
yeah, but
it's
like I
physics.
guess it's what I was saying is that I don't know. When I first got into science, I never thought about that. I just thought about like, oh, how it's so cool that we're making the world a better place, which on average it definitely is. But then one day you realize like, oh, it could be used for a lot of bad in the wrong hands. Also, the ship lens, the Archimedes lens, was it? Yeah, the idea that you could use like basically a giant mirror and put them on sail ships and then point them at other sail ships to burn them down. Did they actually? Is there proof that that existed? I don't think there's.
Well, I thought they put it on like the city, like a city walls or something to actually burn a ship coming. I don't think there's a real evidence on it, but
Yeah, I think
theoretically
there
it's
was like
possible.
evidence that there's evidence
Is
that
it though?
Archimedes had the
Oh,
idea, but I don't think there's evidence that they actually did it.
but I think theoretically it might not be possible because you have to have like a huge lens to make that possible, like to ignite. Um, so that might not be true. I have to
I
do the calculation to figure it out, but I don't think it's really is.
So
yeah.
MythBusters tested this a while ago, and they found that it didn't work even with a couple hundred people. And that was using like modern mirrors that were highly polished, which wouldn't have existed back then. So chances are it did not
Yeah,
exist.
because
And even when they tested it, it didn't work.
the sunlight that it is a simple calculation really because it's just like, oh, what's the energy per area that the sun have, right? Like if you focus that, let's say you have a meter square of mirror, and if all of that energy focus into, let's say, 10 centimeters square on a ship, would that ignite the wood? Well, it's kind of simple-ish calculation, but I don't think the sun have that much energy to ignite the wood just from a mirror.
Um, I mean, we do have solar farms nowadays where instead of being solar panels, they just reflect and then they're able to melt salt. So they're molten salt, solar powered farms or solar energy plants, which are interesting. But going back to
Oh,
Liam's thorn,
what did I not like in the last 8 years? Hmm. Well, I definitely don't like how little money grad students make. And we're lucky too. Some grad students pay for their degrees. Like at least we're getting paid, but it feels criminal how much we get paid for what we do sometimes. I'm sure I have like a more entertaining thorn than that, but that's definitely a big one. I'd like to make a livable amount of money, please.
Well, I think I said, did Patrick go with the second one yet?
yeah. So thinking about it, I think my thorn, in a general sense, over the past 8 years, has been boundaries. Because as grad students and as undergraduate students, we're still learning boundaries and we aren't really given set boundaries. Like, I remember many late nights and early mornings working on homework assignments for courses, or later on, doing work for 12 to 14 hours a day and being in the same building, just trying to get things done to meet the expectations of professors or collaborators or things like that. And even nowadays, trying to establish boundaries is something that's not really taught or really, I guess, well established, because we see professors that are replying to emails at 3 a.m. before teaching at 7 a.m. and then meetings all day and then not really sleeping at all. And so I think that kind of toxic culture of your work is your life and your life is your work has really been detrimental at times. I mean, it's beneficial occasionally, but I find it's much better to have a balance and developing those boundaries with what you're doing. And yeah, it's okay to think about work outside of work. Like Liam said, he woke up from a dream and was able to figure some things out and then go back to sleep, which is cool. You're passionate about it. But it's when it gets to the breaking point that really sucks. And I mean, there were several breaking points over the past 8 years, and a lot of them in undergraduate where you're under a lot of pressure. I can't imagine now having to take 5 courses a semester or 6 courses, but we still managed it and we still
It's
passed. Um,
it
I mean,
it's
we're here
so
now,
funny
so
that
it's
you said that. This
yeah.
morning I was brushing my teeth. Like I woke up to like I didn't go into work today, but I woke up and I was like gonna go to my I made some breakfast, go to my laptop, start work or whatever. But I was brushing my teeth in the mirror and I was thinking the exact thought, like, I'm so glad I don't have to take 5 courses a semester right now. Like I'm so glad that part of my life is over with. Um, but I think my thorn and your thorn kind of
Yeah.
we could combine them into one big thorn, which I mean maybe I don't know how to say it very well, but it's that I don't like universities. I think academia is I think it's kind of bad. Um, at least the way we've experienced it, where it's just so yeah, it boundaries. Universities, you're a grad student, so you're a worker and a student, And whenever it's convenient for them, they'll call you a student, and whenever it's convenient for them, they'll call you a worker. So it's like I don't get at my university, I don't get on the gym membership or whatever because I'm an employee, I'm not a student. But then I don't get the employee benefits because I'm a student, I'm not an employee. Like they kind of just put you in whatever category works. And it's been that way for a while. And you don't get paid much to do really highly educated work. And university's a business. I get it. They're there to make money, but they're under like the shroud that they're this place that's making the world more noble and great for everyone, when in reality they're just a business. So you always got to keep that in mind.
I would agree that academia can be quite toxic, and it changes from field to field. Like, I find it less toxic what I'm doing now compared to what I was doing before, where like profs will disappear for a week because they went hiking. But that's also earth sciences, and most students do that too. But yeah, it's certainly a good example of bad boundaries in academia, and especially in a university setting where you're underpaid. So that's already a boundary that's being pushed. Like, you are not getting paid for the work that you're doing, uh, and you get the honor of saying, "Oh, I graduate with a master's or a doctorate or even an undergraduate," for having to pay money to a university, who will then give you an accreditation. However, how many years of your life has it taken off? And then we shouldn't get too much into it, but there's the whole publish or perish mindset, where if you aren't publishing and you aren't having results, then the chances of you getting a solid job or further funding or things like that is just diminished greatly. And I do see inklings of change, but that's another thing with academia is once you're tenured, once you're there until you want to leave. And sometimes they can force you to leave or pressure you to leave, but the fact that there's so little turnover because there's a lot of older people in the field who may not be contributing as much as, say, a younger person, then that gets into issues too. But that could be a whole episode itself.
Well, I want to top everything. Well, I think the last rose, right? And the top of the sandwich, as you guys mentioned, is that to me, I think Patrick said before, is the people, but I want to take a different take on it, because I feel like for the past 8 years, I met people from different walks of life, and one thing we have common is that physics. It's kind of a strange thing to say, right? Like it's just something we have in common, like a field or a subject. But deep down, we kind of know that we have similar, or at least some semblance of the same ideology or the same drive that drive us. So in a way, when I meet new physicists, I look at them like, doesn't matter what they look like, what they feel like. And it's just like, we are here, we are on a mission together. So there's this like camaraderie that you have with physicists that just comes out of nowhere. Just like I don't need to know them. At first, you're like, oh, you're in physics too. And there's something that click. Like you go to conferences, you meet new physicists, they do completely different things in different fields, completely, exclusive from you. But you realize they also have the same idea of finding out the truth of the world. And there's this common thing that make you get along with people. And I think that's such a beautiful thing to have when you do science, right? Because it's not just you. There is this collective effort of figuring out this physical world, not just physicists. There are chemists, biologists, that people who do science to want to figure this out. That in a way, when you meet another scientist who do it professionally, not just trying to like do it as a hobby or just learning it slowly or like in the fundamentally, it's just there's a unique feeling, at least to me, in my experience when I meet another scientist, like, all right, we're on this boat together. We don't know where it's gonna go, We try our best to make us go further to this depth and tumultuous sea of chaotic sea of knowledge. We don't know where we're gonna end up, but we are on the same boat. So now I can tell. I like to know. I would like to know what you research. If I meet a biologist, lepidopterist, people would study butterflies and stuff. I would love to hear what they have to say, and maybe it's just a normal human thing because I still want to hear what people in the arts and in like soft science, psychology, sociology, all these arts things have to say too. But I think being in academia or in university, there is this sense of collective effort, of collective, um, push for humanity. It's not about just me. It's not really about my family, not about my community, but it's about the entire world. It's kind of in a way it's arrogant thing to say. Oh, I'm doing this for the world. But really, when you publish a paper, it's for everyone, well, mostly for like open access stuff, right? But they also like you publish a private journal, it's gonna stay there for people who are interested and are capable of understanding it, and you are building upon this mountains of humanity that your forefathers, your ancestors has spend their blood and tears on it. So I think being a part of that, being able to relate to people who are part of that is a big thing. So in the past 8 years, that was a pretty great feeling and I think experience. So I think we need some last roses.
So I guess mine kind of relates to yours, Pheely. That I just one of the great things about what I do and our jobs are that we get to travel the world for conferences and collaborations and things like that. So I mean, I haven't done too much traveling yet, but I've gone to England, I've gone to Italy, and I really want to go all these other places because there's different conferences happening and different things happening. And it's just been like it's been such a good time going to work with people from different cultures and learning about how they got into physics or science and how things happen in different parts of the world. It's been awesome and I want more of that. And that's one of my favorite parts about what I do now is these kind of international collaborations. And even though I work in a small group and I don't have too many of them, they're nice. So going over to Italy for my analog gravity conference, which was the first kind of conference in my field that I got to attend, I got to meet all of these people from around Europe and some other parts of the world who work in my field. And yeah, talking to them was awesome because we all kind of spoke the same language, even though we'd never met. And we're from very different backgrounds. And I got on their good side. Luckily, I had a very nice presentation that they enjoyed for whatever reason. So they'll remember my name, and I managed to get in that community. Um, yeah, that's my final rose was basically getting to see the world, learn about other people.
That's a very good rose, and that's definitely a highlight of academia I found is again the people and also getting to travel because despite recent pandemics, it's still encouraged to go travel and meet different people in different places. And of course, when it's funded, that's even better. As for a rose for myself, I mean, of course, I agree with what both of you touched on. But I think the flexibility that's offered from, I guess at this point, a career in academics, whether it's in your undergraduate and you want to take a bit longer, you can absolutely do that. We have a very good friend of ours who took 5 years to do their undergrad instead of 4, and I think they're all the better for it because we all get to graduate together. And also the flexibility, especially now, of being able to work from home when you need to, which is, again, more common now, but was still decently common during the past few years before the pandemic. And then you also have the flexibility to take your work where you go. So you don't necessarily need to be always, say, in a lab or in an office working on a computer, but you can pick up a computer, you can write wherever you want, you can go write on a beach if you want, or on a boat, or a train, or a plane. And the fact that writing is such a big part of academia and academics, it's very convenient that you can just kind of pick up your stuff and go. Now, for experimentalists, it's a little bit harder, but even then, you have to write at some point. And so that flexibility is nice, and also the flexibility of what you want to do in the future. Now, I remember in physics, it was a bit more limited, but in earth sciences, there's so many different job opportunities and career opportunities, whether you want to work with the government or different space agencies or the private industry or go into academia or none of those things and uh, take an education degree and go become a high school teacher. There's a lot of flexibility, and especially with physics, having done an undergraduate degree in physics, we got to see what a lot of people did afterwards. And it was everything from going into physics to becoming a lawyer or a doctor, a medical doctor, that is, or something entirely different. So I really appreciate the flexibility that being a scientist and a researcher, maybe not so much a student because, eh, um, but there's a lot of flexibility in academics and in research, which is very nice.
Yeah, I think all those stuff are pretty, I think, common between us, right? Like, I think because we have been together for quite a while. Now I think about it, it's like 7, 8 years that, like, time flew by because those year in undergrad kind of flew almost literally, just flew past me. It felt long at the time, but now it just felt like just a glimpse, like the blink of an eye.
Um, just not to detract from the conversation too much, but the 8 years have gone past quite quickly. And I just want to say that the next month or so that we'll be having a break will also go by quite quickly, um, especially for you, the listener. And in that break, you might be wanting to figure out, oh, I have a question about this episode, or oh, I want to be a guest on the upcoming season. Well, I'm just going to shoehorn this in here because there's no other place to do it, but you can contact us through a number of different ways, especially in your times of loneliness when you are absent from or when we are absent from your life. So you can first find us through email. We are hyperthesis.podcast@gmail.com. So you can send us an email with questions, comments, or if you would like to be a guest on our show. Not all of our episodes are just us talking about things. If this is your first episode, go back to a different one and listen to it. And we have had guests. We are more than happy to have guests on our show. So if you're an expert in your area, reach out to us. You can also find us on Instagram. We are at the Hyperthesis. There you will get posts of when we post episodes, as well as other updates, including when the season will be ending. Or I guess the next season will be starting. So follow us on Instagram. Feel free to leave comments or send us a DM. Now, if you are listening to us, chances are you found us on some sort of podcasting service, whether it's Apple Podcasts, Google Podcast, Audible. We are based out of Spotify, but we are on pretty much any podcasting service that you can find. We are also on YouTube. You can subscribe to us, like our videos. I think you might be able to leave comments. I haven't checked those settings in a while, and we are mostly caught up with our YouTube videos. So by the time season 5 comes out, all our seasons should be up on YouTube, and you can view the very high definition, lovely visuals that go with our recordings. So, however you want to contact us and listen to us, feel free to share us, rate us if you can on your platform, follow us, subscribe, and reach out if you are interested, if you have questions, or if you just want to talk
Patrick,
about
I just want to
science.
thank you for always doing the outro because it started off quite small. I think when we started doing the podcast, it was like, oh, here's our one place you can reach us, and send us an email, and now it's like this huge 5-minute spiel about all the different platforms and how to be a guest. And yeah, you do it very well, better than I ever could, and it feels like a lot of effort. So thank you,
Thank you very much, sir.
Pheely. Thank you
All
for
right.
editing
And I'm
as well.
always pleased to do it.
Oh my god, I could never.
Yes, thank you, Pheely, for editing. Big job.
All right, so I think for the last topic before we kind of fizzle out, because it's quite a long episode. This is we didn't mention it in the beginning, but that we planning to just have a casual conversation where we just relax in our own way and just talk about things. So I think the last things to chat about when we come up with bunch of random topics and questions, we have some list of questions that I think we can answer and pass around. And I think the first one is, what is our favorite episode so far? 4 seasons. Oh, imagine. It's like a year-ish, right? So, well, favorite
Year and a
episode of
half.
the whole show. Wow, that's hard
I
to
have
pick,
to.
isn't it? Like, to me, it's like I'm just trying to
I'm looking at
remember.
the list right now because
um,
yeah, there's no way I could remember.
yeah, it is tough to pick, right? Like, I think I like all the episodes we do. But if I have to pick one, I think I have to pick one with a guest. Obviously, right? Um, the guest I would pick I think I would pick Cat's
Mm.
episode on FM with atomic force microscopy, because I think it's very interesting, and also she has very interesting stuff to say. And Kat and I, we like to delve into philosophy quite a bit, and it's always fun to see, and we always has great time. And I think even after the recording finished, we talk about a bunch of stuff, and yeah, and it's nice to see that she's succeeding in what she really wants to do, and her shift from doing kind of theoretical slash computational physics to something that's really completely experimental. And she's having such a great time at Gill. She's doing PhD there now, and it's such a fulfilling what's it called moment, right? I'm not even a parent, right? But it's like, wow, I'm glad everything worked out well. So I think that's my favorite episode. Just hear what's been happening with their lives.
Yeah, every episode's really good, I find, and all the guests are awesome. But I'll stick with what you did, Feely, and I'll choose a guest episode. I really liked Andrew Kovacic, who was a guest at one point, because he's got some deep thoughts, and he's just a fun guy to talk to. Like, it's really chill. It's always super interesting topics. I just very much enjoyed him here. It was a very fun. I just remember it being a fun episode, like the conversations we were having.
I will separate from the group because I
Oh, me
think all
too.
the guests were great, and I don't want to pick a favorite. But I really liked our episodes. We did a couple of them, but on kind of sci-fi related technology and theories, and how they could be possible or how they ended up becoming real things. So I really liked it when we delved into, say, sci-fi in the movies and talked about what would actually be possible, and also the aspects of fiction that are reflected in actual science and what actual science is reflected in fiction. So I think we had 3 of those episodes total, and those
Okay,
were
yeah. If
some
you
of my
want to go
favorites.
based on like the topic of the episode, I definitely like Andrews a lot too, because it's where gravity meets quantum mechanics. This is research, and it's this where Java gravity stuff that relates to me. But I like the simpler episodes a lot too. I like the music episode. I like the how we see things episode. I like the senses. I like learning the science of human senses a lot. So those episodes are always really nice to me. And I really like the biomimicry one as well. But we mentioned it earlier, but
Well, I think the next one on the list is the underrated theory or knowledge that um that's not talked about as much. To me, maybe it might sound like a meme one to you, Liam, but to me, it's a one electron theory.
No.
Yeah, it is. Because I like paradoxical theory that really challenge you to think outside the box, even though it might not be true. I don't think it's really true, but it really force you to think outside of the box. Because normally every accept that there are electrons around, right? And then this kind of concept force you to start from the premise that there's only one electron. Then can you form a logical thought from that theory to have some coherent argument to talk to other scientists? And that's fundamentally it's really important, not just for argument's sake, but as a scientist to be able to come up with a new idea and then formulate it, try to be consistent to the known scientific regime. And to me that's very important. That's why I like having these like controversial, like, absurd claims about one electron theory. Well, what happened to me was that, what if there's only one electron? Can you write down these equations the same way? Can you think about these theory the same way? Even though it might not be true, to me, the same way as like string theory. That's would be my second answer. It'd be like string theory. Even though we know it's not very practical to use it, it's still a rigorous and beautiful theory to think about the reality. It's it's not useless. So in the same manner, I would say that the one electron theory provide that out of the box experience for us to think about, can we apply our understanding of physics to this absurd claim. And if we can find something that's coherent and consistent, maybe there's something to it, or maybe not. Or maybe the whole scientific thing is just making arguments that make some sense. So the reason I really like, I think, is underrated, not just because it's absurd, but it's provide a perspective that that's not the norm. And I believe that it's necessary to recognize that those theory, no matter how out of this world they are, is vital to maintain healthy scientific discussions. So that's my reasoning. Well, next to you guys.
Patrick?
Okay, I kind of have
I'm still thinking
two
about
off
mine.
the
Don't
top
laugh
of my
at me.
head. So generally, I think an not so much underrated or even unknown, but something that is misconceived a lot is statistics and how statistics works, and just the different calculations and meaning behind the representation of statistics. I think generally that's a huge problem where things can get misconstrued. Like, for example, if you look at the weather forecast and it says it's a 50% chance of rain, then people will perceive that differently depending on their background and how they've been taught statistics, if they've been taught at all. Whereas other things like understanding statistics with rare events, which is very important in particle physics and also important in real life, because there are people that think like, oh, well, I will get struck by lightning sometime in my life because it happened to this person, but statistically it will not. Even then it could happen. So I think just general knowledge about statistics really needs to be better thought out and presented to the general public. And an underrated thing that it's definitely not as well known about is something called mycorrhiza, which is something I'm learning about a lot more, especially for one of my projects. But mycorrhiza is a symbiotic relationship between fungi and plants. And it comes from the Greek word, which essentially means fungus root. And so it's a symbiotic relationship between fungi and the roots of plants, in which the fungi are able to feed different types of nutrients and produce different types of nutrients, that are fed into the plant, and in exchange, they get different nutrients from the plant.
I learned that. I think it's like grade 8 biology is a mycorrhiza. I haven't heard that word for so long because we were doing some like agriculture class, and it was like, oh yeah, because these kind of plant needs fungi on their roots, because you literally dig up and you can see this like thing. It's like that's not part. It's like the roots, but it's like covered in this fungi. Like no, it really helps plant absorb nutrients. It's like what? And yeah, I didn't expect to hear this word come out. Like I haven't heard that word for like the past 10 years.
It's a core memory.
Yeah, no, I had never really heard of it. Like I'd heard it mentioned before, but actually researching it, it's phenomenal. And like the fact that there are massive organisms that are just fungi in the dirt, in the soil, in the earth that make up a very large biomass. It's very cool to learn about, and it's under almost anyone's feet. If you have plants around, like a forest or some grass, then chances are that there will be mycorrhiza. And the fact that it's everywhere and is almost necessary for uh, plants and especially trees to survive, and might be one of the reasons why we have forests, along with the fact that the fungi in this relationship can act as communication networks between trees is just astounding. And also the fact that we know so little about how these relationships and how these fungi and tree interactions function is astounding, and just shows that there's a lot of mystery for something so common and uh, dense and popular. So mycorrhiza is definitely something that's underrated that I think people
Yeah,
should
I
learn
never
about.
knew about that. So that is good that I now know. And I agree with you about statistics. Statistics, like I never took a statistics course, even though it's important for all science, and even in like quantum mechanics, it's just statistics basically. Um, so I agree with that. But I'm gonna. What is the most underrated thing that I think deserves bigger praise or knowledge about? I'm gonna answer what is something I think needs more attention in physics. So slightly different question, but I think the way inertial and non-inertial frames, the way that they're taught in physics, is done very badly, both classically and through special relativity. So how like you when someone's new to physics, you might hear them say like, "Oh, centrifugal force isn't real; it's a fictitious force," or stuff like that, which maybe if you haven't done a physics degree, you don't know what I'm talking about. Um, but inertial frames, you have to treat them differently. You have to put in these additional forces to Newton's law. They don't just kind of automatically pop up. At least when you with Newton's law, you can do other ways where they show up, like Lagrangian methods and stuff. But I think I think the way we were taught classical mechanics was really well done in that sense. Like I have a very good understanding of inertial and non-inertial frames in classical physics, but even in relativity, there no one ever seems to talk about them. Many physicists, people who have an undergraduate degree in physics, they'll tell you that Lorentz transformations or special relativity is only valid in non-inertial frames, or sorry, in inertial frames. And when I say inertial frame, I mean um, if you're an observer and you're moving with a constant velocity, or you're not moving at all, so you're not accelerating. When you work in these inertial frames in physics, the math is way easier essentially. But people don't understand that you can do special relativity in non inertial frames. It's just the way it's taught. For some reason, everyone thinks that it has to be an inertial frame, and it's way easier and way better to work in an inertial frame. But the universe is inherently non inertial. Things accelerate, right? And special relativity, you can do it in non-inertial frames, and general relativity is all about non-inertial frames, and people just don't have a very good understanding of how they work classically and relativistically, and even I don't have a good understanding of how they work relativistically. I have a decent one, but there's still things that confuse me when I see them, and I have to really think about them. So I just think that should get more attention in undergraduate physics classes.
All right. I think I'm going to the next question before the last question, which nobody knows. I'm about to write, but this question is about so what topic that we would like to delve into to explore, but we don't have time per se. This is a matter of priority. But I would like to go into this in a non-physics or non-science topic. So it's make it a little bit challenging. To me, I'll start is etymology. So etymology is a study of the origin of words, and basically your words as parents, right? Like where do it come from? Every word, every name we mention is come from some word. That's why I like to know people's middle name and what their name means. Which, and I think in more Western culture, names don't mean much. It depends on if it's from like Greek or like very like what's it called ancient language that's like that's your name was derived from, or maybe biblical. But I think in my culture everybody's name usually have a meaning, and I like to like know every meaning of words that I utter. So the utterance of a word to me is powerful, so I want to know each and every component of what I pronounce. And I think it's a fun thing to do. So when I learn about people's names, I want to know what they mean, or like the words where they come from. Like like is that have like German origin, or does it have like French origin? Patrick probably know like Schadenfreude, right? Like the words, the happiness you gain from other people's misery is from the German word. And there are all other words in English language that come from different language, like the old German, Latin, French. Even in my own language, it's hard to come from Cambodia. That's why I know some Sanskrit words. I know tiny bit of a Chinese words, and all different parts that make up my language. And also English language is so deeply entrenched in many different ancient languages. So etymology, if someday, or I try to learn more and more every day, but I just don't have time to specialize as much as I want to specialize in physics. So I want to hear what other of you guys have. Don't say bagpipes. I'm just
What?
cutting you there.
Oh, well, I already spend a lot of time doing bagpipe stuff, but yeah, I'm gonna come at this from a more research point of view instead of hobby or other interest point of view. Yeah, I want to do. Well, I wasn't gonna say bagpipes, but you mentioned it. One thing I want to do is a lot more. I want to do kind of bagpipe research because there's papers out there about how sound travels through pipes and how there's people who do like bagpipe related stuff, although it's not very common and the literature is very old and outdated. And there's things you can do inside the instrument to make it better. It's a really complicated instrument with many degrees of freedom. Um, but that's not what I want to talk about. But that is definitely some branch of physics I want to get into at some point in my life. It'll be like my hobby branch of physics. It won't be my main research, but it'll be something I just do when I'm bored. And I have this other idea for for some theory, which I want to get into, where I notice that when you pour water out of a cup a certain way, you get this interference pattern in the spout, and I think it's very much related to the I don't know if this is true or not, but I think it's very much related to this catastrophe theory stuff and the actual image that we use for our podcast's cover photo. So that's been in the back of my mind for a few,
Like airy
like a
function
Piercy
stuff.
function. It kind of looks like that, but a Piercy
Piercy, not
function is
airy.
just there's airy functions in Piercy functions, so same thing basically. But this,
Is there anything non physics that
well, let me finish this point first. Is that I have this idea. It's been in the back of my head for a few years now, and it's just something I want to look into. I want to do some math and see what's causing this phenomenon. And I could be wrong, but this is one of these things where I look at it, I'm like, yeah, it kind of looks like something I know about, so maybe it is something I know about, and I just haven't gotten to it yet. Um, so that's something I'd love to delve into and explore. But is there a topic I want to get into that's not physics? Well, like we said earlier, there's just so much on our planet that we can do before we die that there's not enough time to do it in a single life. And I would love to play many, many different instruments. I played piano for a long time, and I'm a competitive bagpiper now, and have been for a long time. I really like music. I owned a French horn I bought at one point, and I really wanted to learn French horn, but I ended up many years had passed and I never played it, so I sold it to someone who wanted to play it. So I
Yeah, maybe I should try going back to playing the violin, but I just never, the type of music just doesn't resonate with me anymore. It's
yeah,
just
so I
weird.
think there's many things that I want to get into. I think other instruments. I'm trying to think of one, but also learning another language. That's something that I'm slowly working on, but I always wanted to learn another language, and my whole life I've been very bad at languages. I'm in grade 12, I maybe had like a grade 8 English level, and only during university and having to read all these papers and write so much did my English kind of catch up. And even then, it's not as strong as it should be right now. So I barely speak English, but I'd love to speak another language. So that's
You gotta learn Gaelic. That's it. Embrace the
well,
bagpiping.
I
Just learn
worked at
Gaelic.
the Gaelic College in Cape Breton, Nova Scotia. I was their duty bagpiper, so I would stand in a parking lot 8 hours a day and play bagpipes, which was it was a hot time. It was very hot standing in a parking lot wearing a kilt playing bagpipes, but it was really good experience, and they paid me for it and all that, so it was awesome. It was a wicked summer job. So I picked up a little bit of Gaelic, and actually, our undergraduate university had a Gaelic class that I took, but I really struggled with it because I wanted to get into another language, but it's a very old language, Scottish Gaelic, and it's the modern version of Scottish Gaelic. There's many other types of them, but I don't remember very much about it, honestly. It just I always had such a hard time being interested in languages, but I'm starting to get into Spanish a little bit, and I'm actually like on Duolingo. I'm kind of excited about it actually. Duolingo has been really fun. I kind of like trying. I talk to my cat in Spanish to practice. I call him El Gato Oxidado, which is like the rustic cat, and I have
I'm sure Rusty
yeah. He
appreciates
has
that.
no idea what's going on. He just thinks I'm mumbling to myself. But
Hey, you think he has no idea what's going on. That's the
true, yeah.
difference.
I guess
Anyways, we go move on to Patrick. Anything would you like to delve
Yeah.
into? Not physics.
I mean, well, not physics or science, since I don't do physics too much anymore. But I would say automation and robotics. Super cool stuff. I did robotics in grade school. It was a lot of fun. I started out with Lego robots and doing automation that way. But I've grown to learn a number of computer programming languages, and I love computer programming. And with that, you see real live results. And now that I'm working with drones and other automated technologies, makes me want to build them and test them and develop them, and also work on other automated systems just to make life easier or more fun, or they're just fun projects to work on. I already played some instruments and um, do that kind of thing, so I'm already kind of there. And then I guess the other thing that I want to delve into and really just have as a hobby is fixing up cars. I always like mechanical systems, and complex mechanical systems interest me. So one of my goals in life is to make a car from scratch. I don't think that will ever happen, but with electric cars, who knows? They're pretty fun and easier to build. So yeah, those two things are things I would like to get into once I have more time, but that might be a couple of years away. So moving on, Pheely, to wrap up this episode and to really finalize all these questions, you have asked this question to every guest that we've had on the show. And I think it's time to ask you this question now. But what are
I
your
think he was going
hopes
to ask
and
us that
dreams?
just now because he said
I
yeah, I
know.
know you
Well,
did.
we beat him to it.
Yeah, I know. I wrote it down and you took it. But yeah, hopes and dreams. Things change, I think, drastically for the past, actually, for the past 3 years or so. What I think, who I am, and what I want to be, it has so much difference that I couldn't even like fathom. Because I think when I look back in retrospect, what I thought was my hopes and dreams feel or appear so childish now, which I might have the same thing, and I would say the same thing might be next 5 years later, right? But the one of the reason I ask people what their hopes and dreams is there something that out of the regime of career. Well, part of it is career, but I wanted them people to think about what do they really want in life, right? And and when it comes back to me, it's still a difficult question, right? To, in my opinion, is the most difficult question you can ask in life. What is the good life? What is your hopes and dreams? So to answer that question, after I digress for quite a bit, is that my hopes and dream is that I can achieve my career goals. That's one of them. Hopes that I can achieve my career goals. Not in terms. I don't want to win any awards. I don't want to win any of this. Recognition is a different thing to me. I just really, truly want to figure out how to conduct myself in the moral way. Actually, my whole hopes and dreams is not in science at all. Like I actually that's part of science to me. That's a craft. That's this thing I do outside of being a human being, in terms of like a moral human being. I want to figure out how to be just, how to how to what is justice, what is a moral thing I could do in life, and because being a moral person would lead me to have the best life, a good life. And I have been in debate with myself and some of my colleagues, people I know quite a bit, on what is a moral life. And to me, that is the truth of the world. So my hopes and dream is really to figure out what is the meaning of life in the philosophical sense, really, in the ethical sense. What is a proper way to conduct life? And by that, I try to listen to different authors, read different authors, listen to different speakers on ethics, even to religions, and I try to study different religions. And my goal in hopes and dream is to figure it out and hopefully be able to guide my descendants, the people who are younger than me, to have a better life. And that is my hopes and dreams. It's not very scientific, it's not physics at all, because to me, physics is part of life that is career. It's craft, it's techne. It's more technical word. Right? It's a craft that I do to fulfill, to feed myself. But what truly give human beings true fulfillment, in my opinion, right now, that could change, is to figure out how to live a good life, or figure out what is a good life. And that to me is through imagination, through ethics, through morals, through studying of the divine and art, and part of it is of the science. So it's a loaded question, which I love to answer in a loaded answers. So that is my long question, hopes and dreams, which I would bounce to you guys. See what happens.
Well, yeah, I don't think I can top that. Mine's a lot more boring and like mine's just like kind of a bucket list. Um, yeah, I guess, I want to be a good person. I want to morally do the right things, of course. But I think my hopes and dreams are A, I want to have a successful physics career, whatever that means. I don't care if I'm a Nobel Prize winner. I don't care if, I'm super well known. I just want to do good science that contributes to our knowledge. I want good papers. I want people to look at those and be like, "Oh, that's a nice paper." And I want to teach. I really like teaching. It's very satisfying to help someone understand something that they couldn't. I don't know. It's really good. So that's hope and dream number one. Hope and dream number two is I want to play in a grade one pipe band at some point in my life. So the way pipe and drum bands work, for those, I mean, we said it many times, but we said it today. I'm a bagpiper. Um, grade five is the lowest level of competition, and that's where people who are new starter, they don't play as much. So Patrick here over there, Patrick's in a grade five band right now because you don't dedicate 90% of your life to bagpipes like a grade one player would. So grade five is the lowest, grade one's the highest. I'm in the middle somewhere, and it's such an easy instrument to pick up and such a hard instrument to master, which is why 80% of people who play it are just kind of, I don't want to say bad, but not as good as the grade one players for sure. So one of my life goals is to just play in a grade one pipe band. I just want to be in a good solid pipe band. I'm in a really good solid pipe band right now, but grade one is like that's where everyone is very much experienced and good at what they do. It's like the professional level of pipe bands. And then I think my final hope and dream is just I want to travel the world and understand other people's cultures. And I just like, we're all academics here. We love learning. And it feels like the world is as small as it's ever been now. We can travel very easily. We have the internet. We can learn a lot about it. And it just feels kind of wrong to just live in one spot your whole life and do nothing else. And, some people, that's what they want, and that's fine. But the way I want to do things is I want to travel around. I want to experience other cultures, meet other people. I think it feels like the right thing to do for me.
Okay. Yeah, I guess I'm last. Uh, well, in terms of hopes and dreams for careers, like what we usually ask guests, I don't know at this point what I want to do in the future. I quite like the area I'm researching now. There are some things I would change, but we'll see how those are implemented in the future. But I agree with Liam that in whatever aspect I'm in and whatever capacity I may be able to, I would like to teach. Uh, one of my fallbacks is high school physics teacher, just because I didn't have the best one in high school, and I want to give students a good experience and maybe encourage them to go into physics or some other scientific field. But I also quite love teaching and explaining. Part of the reason why I'm here for this podcast is just we get to explain complex topics in sometimes easy to understand ways. Sometimes that's tricky, but it's also a fun challenge to try and help people understand. And I think education is very powerful, especially with everything going on and the access to disinformation that we have along with information. So I think it's important to educate not only in the sciences, but also in logic and morality, as Pheely was discussing earlier. So whatever I'm doing, I hope that there's a teaching aspect to it
My
at the very
one
least.
hope and dream that I forgot to mention was that this podcast reaches 100 episodes. I think that would be very fun. And I think we can reach 100 episodes. I don't know what we'll do after, but I want to reach at least 100. That's my goal because I think that's a nice number.
Going back, just another hope and dream I have, not necessarily with the career, but just generally, is to make the world a better place than when I came into it. So, I mean, it's getting better now, but I'm hoping that I can contribute in some way. And that's part of the reason why I switched from physics into environmental sciences. Was it gives me the opportunity to work with things that are happening on Earth and really try and study what's going on and ways in which we can, if not fix things, at least start to make them better. So
There's a
that's
very
my
nice
other hope and
Einstein
dream.
quote, which is something along the lines of, "Don't try to be a man of success, but rather a man of value." And I try and live by that. And it sounds like that's what you want to do too, Patrick.
Yeah. Einstein was a good, smart man.
Well, I think to end it all, I don't know if any of my first year TA students listening to this, but I like to end things starting with a quote from things I like. So this is kind of like a what's it called double quote, because when I first read this, I didn't understand it that much. It's part of the Tales of Two Cities by Charles Dickens, but it was quoted again in The Dark Knight Rises by Christopher Nolan, and it's one of the most, I think, profound thing that I have heard. And I want to end the episode with this before we get to the 5th season, hopefully, because this is the eulogy to the Bruce Wayne. I think you guys know too. I see a beautiful city and a brilliant people rising from this abyss. I see the life for which I lay down my life, peaceful, useful, prosperous, and happy. I see that I hold a sanctuary in their hearts and in the hearts of their descendants, generations hence. It is a far, far better thing that I do than I have ever done. It is a far, far better rest that I go than I have ever known. I think that's to sum up the hopes and dream. Have a good night, everybody, and see you guys next season. Take care.
Thanks for listening to the Hyperthesis podcast, the only podcast that ends with a Batman quote.
Bye, everyone.